And it is very hard to understand if the request is going to take 10 seconds or 2 minutes. And if there are coincidentally 2-3 parallel large requests, now you're out of memory. So like tuning the agent is something completely different to the regular application because you know how spiky it looks from the regular like metrics. Oh, perfect. Syncing monorepo, wonderful question. Thank you very much for this one. So another problem that we have, I didn't like want to put it on slides, but actually, when we deploy the agent, or more precisely, when we compile it into a container, this is the time when we do the git pull. So all the repositories and the information within them, they are valid up to that point. So if the agent would be running 2 days straight, yes, it would have a stale git repositories. The thing is that this doesn't have any, if you don't, of course, want to, in addition, if you are not letting your agent to access GitLab, this doesn't have like easy solution. So our solution currently is that we on some cron try to redeploy the agent to have fresh gits, but we could also having it git pull on each 10th like request, something like this. It wouldn't be as effective. It would spend some time, tokens, etc. But maybe this would be more preferable. Also, the problem is that you are deciding, or you are letting more precisely the agent decide based on the status of your Git. We are, for example, using Puppet. Puppet has a typical period of 30 minutes to be applied. So does the Git really like mirror one-to-one exactly what you have in production? No, it does not. There are some discrepancies. So you need to do some trade-offs over here, just to be clear. There will be some stale information. You will need to understand that there is such a thing and how to address it, of course. Sorry, what do you mean by status page probably over here? Not sure if I understand what the status page in this context is. Yeah. I know about this, because we have just changed the workflow for the Write status page, and there are probably like 3 human approvals to get anything to the status page. So it's completely disconnected right now. Cost limiter. Oh yes, cost limiter. There were rate limiters in the past. Now we do have cost limiters, or more precisely, token limiters. So I'm very scared because I have heard just today that there are some people who have like unlimited budget on tokens. I'm not like one of those, and I still spend probably too much. But it's very similar to what you would expect. So in 6 hours, you cannot spend more than X tokens. If you are spending already more, just say politely, sorry, I cannot proceed. That's it. Really. And it's just some safeguard, against being run all the time. Or, for example, we have the automation or the connection to our agent is that it is being asked by Slack. So if, for example, in the response, it would again call itself. There are some protections for it, of course, now, but it could do some cycling over there. So this is just a protection against this. By the way, fun thing is that by humans, it was like never used, and I think that those rate limits are like pretty low. MCP servers, I think, should be treated in the same way as you treat your developer tooling mostly. Or, I mean, in our case, this is some, let's say, auxiliary helper tool for the ops, right? We are not using it directly from a production. So we don't have any automation right now that there would be an alert, it would instantly like try to investigate. So I, as an ops team person, I'm going to Slack and asking an agent for some advice. That's what I do. I mean, given this workflow, we treat it the very same as we, for example, treat Sentry, which is for the developer as some auxiliary tools. If it is down, it is down. It's like a shame, but it doesn't influence the productional workloads at all. I think that it's very same with MCP servers. So the MCP infrastructure, from like my perspective, should be considered as your logging infrastructure, observability infrastructure, anything in this direction. Something that is important, but auxiliary, not the core part of the product. Microservices connection. Oh, this is very, very interesting again. So I come currently from a company that has some combination of a large monolith that is being strangled, you know, each year by year, and we have like 160 microservices, and some of those are based on the monolith actually, so it's some kind of a hybrid setup. Actually, the developers are having problems with these definitions because some services are long abandoned, you know the drill, right? So we don't even have such a thing as having a, let's say, valid README for the services that I would go to each service and there would be written, okay, this service that does X, and it has these consumers, it is consuming from these Kafka topics, something like this. We don't have a thing. In fact, I can remember that we were in an incident and, you know, the managers were asking Claude, hey, can you sum up what the thing does? Because the name of the service was misleading at this particular, and the team, you know, for some reason used some historical surveys, something like this. If we would have it, it would be much more effective because what I haven't showed you and what does not work for us, I need to be again clear on this one, is what impact does this problem have? But you know, originally we were thinking, hey, I will just ask agent, hey, what impact does it have? Does it matter that this service is down or no influence at all? And we don't have it because we are missing exactly this. We are missing the READMEs, Claude MDs, agent MDs, how do you call it, for each service. So the agent would be able to go and investigate what is the connection and give you some hints, some clues, like holistically. Now, when the database is down, you can, you know, because we have some hierarchy that we run in some self-contained units, you can understand which customers are affected, in which data center, which region on the globe, etc. But nothing more than this. If the service is just cleaning up the recycle bin in our application, or if it is serving the homepage, I really don't know. Sorry, I need to stop. Thank you very much.
Okay, thank you. There were like many more questions at Slido, so you can grab David in the back room, yeah, and go ask them. Thank you. Raz, dva. Perfekt. Tak jo, tak ďalší talk bude v rodnom jazyku, nie mojom, ale snáď vašom. Daniel nám porozpráva, Daniel z Alefu, F5 porozpráva nám o NGINX Gateway fabriku, takže je to tvoje.
Tak já děkuju. Dobrý den, moje jméno teda, jak už jste slyšeli, je Daniel Váchal. Já pracuji v Alefu. Alef je distributor F5 tady na českém trhu. A F5 koupila už před nějakou poměrně delší dobou NGINX. A já vám tady chci říct teda něco o NGINXu, o Gateway fabriku, ale zmíním i, jak jsme se k tomu Gateway fabriku dostali, jak jsme se vlastně vůbec dostali ke Gateway API, pardon. A něco teda i k NGINX Ingress kontroleru, protože to by mohlo být pro docela dost lidí zajímavý. Tak jo, celý to teda bude primárně o Kubernetes, protože ten nejlepší důvod, kde použít NGINX, je právě v Kubernetes jako Ingress kontroler. Kubernetes jako takový určitě znáte a dneska se teda budeme soustředit trošku víc na ten Ingress a na to, jak dostat trafik od klientů do nějakého Kubernetes klastru. První řešení, které na to bylo, tak bylo Ingress API, který funguje dobře, ale začalo mít nějaký určitý problémy. Jeden z těch problémů může být třeba to, že umožňuje jenom HTTP trafik. Nicméně je to poměrně jednoduchá věc. Ingress controller a nějaký ingress resource, kterýma routujeme trafik do toho klastru. A všechny ostatní funkcionality, kterými bychom mohli potřebovat nebo který bychom chtěli, tak budeme muset tam nějakým způsobem přidat. A jeden ze způsobů, kterým to tam budeme přidávat, budou anotace. To znamená, to je potom věc, která nám umožní vybrat třeba nějakou load balancovací metodu nebo do toho přidávat nějakou sekuritu a nějakou ochranu pro ten trafik, který nám tam bude posílaný. Co je fajn, je to, že ty anotace jsou jednoduché, jsou to nějaký key value hodnoty, nějaký páry. Co to přináší za problémy je to, že tím, že to, co to API jako implementuje samo o sobě, je tak limitovaný, tak těch anotací může velmi brzo být mnohem víc než toho zbytku té konfigurace. A další problém, který tady s tím byl to, že je to potom hodně vendor specific. Ve chvíli, kdy každý vendor, který implementuje Ingress controller, má svoje anotace a všechno má udělané podle sebe, tak ve chvíli, kdybyste chtěli přecházet na nějaký jiný Ingress controller, tak to bude dost problematický, protože všechny ty anotace budete muset přepsat. Druhá varianta, která je, tak jsou nějaký custom resource definitions a nějaký vendor specific APIs. Zase je tu ten problém, tohle už bude nějakým způsobem víc customizovatelný, bude to hezčí konfigurace, nebude to hromada anotací napsaných pod sebou. Co je tu ale zase problematický, je to, že to bude specifický pro každého výrobce. NGINX je jedním z nich, ale je tu spousta dalších ingress kontrolerů a zase tyhle CRDčka bude mít každý nějaký svoje vlastní. Kubernetes se jednoho dne rozhodlo, že je potřeba tady s tím něco udělat a nějakým způsobem to změnit. Ta změna, která jako přišla nebo která proběhla, tak je vytvoření Gateway API, který má vlastně řešit tyhle ty problémy, které s tím původním Ingress API byly. To znamená, ty featurey, které tam byly, tak Ingress API je samotný má dost limitovaný, stejně tak jako problémy s nějakou rozšiřitelností a ty další věci, o kterých jsme se bavili. Jedna poměrně důležitá věc je třeba to, že je to jenom L7 traffic, jenom HTTP routy. Všechno se to dá přidat pomocí těch vendor APIček, pomocí těch CRDček, nicméně jak jsme říkali, není to úplně ideální. Takže Gateway API by tohleto všechno mělo řešit. A jedna věc, která může být zajímavá pro většinu z vás, je taková myšlenka toho, že v podstatě ta komunita, která stála za tím ingress kontrolerem nebo která vyvíjela ingress NGINX, tak se rozhodla, že ten ingress NGINX už jako nestojí za toho zachraňovat vzhledem k tomu, že se přechází na to Gateway API a že ten ingress NGINX už nebude dál podporovaný. Samozřejmě pro nějaký nový implementace, pro nějaký nový klastry, tak je nám to asi jedno, ale problematický to může být ve chvíli, kdy ten ingress NGINX používáte nebo na něj spoléháte a máte ho jako ve stávajícím klastru. Co tady chci říct, je to, že ingress NGINX končí a to, že nebude dál podporovaný, tak neznamená, že NGINX ingress controller podporovaný nebude. A ten rozdíl mezi nimi je teda to, že NGINX ingress controller je oficiální produkt od F5, vyvíjený F5, a s tím ingress NGINXem nemá svým způsobem nic společného. Ingress NGINX byl vyvíjený Kubernetes komunitou a ten teda teďko umře, ten už není dál podporovaný, není dál vyvíjený, ale NGINX ingress controller, ten od F5, ten nechci říct originál, ale ten prostě vyvíjený dál normálně je a bude dál podporovaný. Tak, nějaké výhody toho NGINX ingress controlleru můžou být to, že ho můžete nasadit v jakýmkoliv prostředí. Asi jakoby, když se budeme bavit o tom, jaký ingress controller si vybrat, tak jeden z důvodů, proč si vybrat právě třeba NGINX, může být to, že ve chvíli, kdy máte nějaký řekněme multicloud nebo hybrid cloud prostředí, tak můžete mít potom ingress controller stejný, ať už vám ten cluster běží na on-premu nebo v nějakém veřejném cloudu. I pokud máte multicluster prostředí, tak zase ten NGINX v tomhletom bude ideální. Je to produkt, který je na trhu kolem 7 let, je pořád dál vyvíjený a díky tomu, jak dlouho existuje, tak už je to poměrně dobře vyvinutý a stabilní produkt, od kterého můžete očekávat, že bude mít velké množství funkcionalit a velké množství jak anotací, tak CRDček. Je třeba jedna zajímavá informace, kterou jsem se dozvěděl z product managementu NGINXu, že oni se víc soustředili na ty CRDčka, aby to bylo hezčí, aby to lépe fungovalo, ale spousta lidí vyžaduje mít tu funkcionalitu v anotacích, takže třeba jedna z věcí, na který se teď pracuje, je, že funkcionality, které už existují v CRDčkách, tak se předělávají i do anotací, protože lidi radši chtějí pracovat s anotacemi než s těma CRDčkama. Takže to jsou věci, které pořád jsou vyvíjený na tom NGINX ingress controlleru. Tak já už jsem trošku mluvil o tom, proč bychom mohli vybrat NGINX jako náš ingress controller, ale jedna věc, kterou já tady ještě chci zmínit, je to, že ty anotace jsou velmi podobné tomu ingress NGINXu a dají se na něj velice snadno přenést, když si všimnete. A teď to asi není úplně šitelný, ale to nevadí, já to řeknu. Ty anotace jsou prakticky stejný, akorát je rozdíl, jestli je to NGINX ingress Kubernetes IO / ta anotace, anebo jestli je to NGINX org / ta anotace. Nicméně ty anotace jsou potom stejný, takže ve chvíli, kdybyste někde měli ingress NGINX a hledali byste, jakým způsobem dál využívat nějaký ingress controller, tak můžete použít ten NGINX a namapovat ty stávající anotace velmi snadno na ty nový, na ty NGINXový. Tak jo, přednáška se jmenuje Kubernetes Gateway Fabric, takže dost bylo o NGINXu, o ingress controlleru a pojďme se podívat na to Gateway API, který nahrazuje to ingress API a má řešit ty problémy, které tam vznikly nějakým způsobem nativně. To znamená, co my potřebujeme řešit? My potřebujeme vyřešit to, že nechceme routovat jenom L7 a HTTP provoz, že bychom chtěli routovat taky třeba L4 provoz, UDP, že bychom v dnešní době možná chtěli routovat nějaký traffic pro LLMK a pro takovouhle umělou inteligenci. Další věc, kterou to Gateway API má vyřešit, je nějaký lepší role-based access control, to znamená, ne všechny ty věci chceme, aby nastavovali stejný lidi, můžou to nastavovat lidi z různých týmů a Gateway API zároveň řeší to, že se dá lépe rozdělit, kdo na co bude sahat, kdo na co bude mít právo pro konfiguraci. Gateway API, teda jako takový, je open source project a je to součástí Kubernetes API nebo jako add-on na Kubernetes API. A je to vlastně ten standard, který zase stejně jako Ingress API může být implementovaný spoustou různých vendorů a zase NGINX bude jedním z nich. Jak to vypadá, tak jako jsme měli nějaký ingress controller, který měl nějaký ingress resources, tak tady to bude trošku rozvětvenější. Tou gateway class to začíná a pak jednotlivý gateway budou zase implementovat nějaký HTTP routy, ale nemusí to tentokrát být HTTP routy, můžou to být TLS routy, můžou to být další jiný routy. A co je tady důležité, je to, že a na každém tom levelu toho objektu tak my můžeme dát vlastně přístup někomu jinému, tak aby se o to starali ty lidi, kteří se o to starat mají. Tak, NGINX Gateway Fabric je teda implementace toho Gateway API od NGINXu, přímo od F5. Je to nějaká evoluce, zase nějakým způsobem to vychází z toho ingress controlleru. A jedna věc, která je tady třeba jiná, tak je to, že ten Gateway Fabric je rozdělený do 2 podů, to znamená control plane toho NGINXu a data plane běží ve 2 různých podech, což dřív u ingress controlleru nebylo. Nicméně všechny ostatní věci, na které jsme u NGINXu zvyklí, možnost nasadit to v jakýmkoliv prostředí, nebo ta sekurita, která přicházela s ingress controllerem, tak je zachovaná i v tom Gateway Fabriku. Je tam pak ještě jeden use case, který nevím, jestli vás bude extra zajímat, ale je tam možnost propojení přímo s hardwareovou F5 s BigIPčkem, tak, aby trafik mohl tect přes BigIPčko a tek na ingress controllery nebo do toho Gateway Fabriku s nativním propojením. Tak jo, ten NGINX Gateway Fabric to Gateway API pokrývá kompletně. A samozřejmě jsou tu zase jiný vendoři, zase další nějaký možný implementace. Jedna věc, kterou jsem za celou dobu nezmínil, možná to zní jako, že je to nějaký placený produkt. Není, NGINX má 2 varianty, open source a plus. A ta plusová varianta je teda nějaká subskripce F5. A ta open sourceová varianta, všechno, co tady já zatím říkám, tak je normálně dostupný v té open sourceové variantě. Akorát ve chvíli, vlastně, kdy stahujete jako NGINX, tak jsou tam ty varianty toho, že buď máte ten NGINX, který je ten NGINX Ingress od jako Kubernetes community, nebo musíte pak jít na ty specifické jako odkazy F5, abyste si stahli z GitHubu ten NGINX, který je vyvíjený tou F5, o kterém já tady mluvím. To, že ten Ingress NGINX byl ukončený, tak byl takový jako největší skok v té implementaci těch gateway fabriků, protože ve chvíli, kdy byl oznámený end of life toho Ingress NGINXu, tak tady vidíme na grafiku, že implementace toho NGINXu jako šla brutálně nahoru, toho gateway fabriku. Tak ještě jedna věc, která může být důležitá, která může být zajímavá, je, co takhle migrace Ingress API na to Gateway API, co když bychom chtěli dostat konfiguraci na Gateway Fabric, tak je tu možnost využít Ingress to Gateway. Podporuje to víc vendorů, není nutný používat to jenom jako na NGINX, ale vy si to můžete stáhnout, v té prezentaci pak bude i jako odkaz kde, ale vyberete si, že chcete provider NGINX a ono vám to vlastně přepíše ty ingressové resursy do těch rout pro ten Gateway Fabric. Tak jo, slidy potom nejspíš budou nějakým způsobem k dispozici, takže odkazy tam jsou, nicméně snadno to najdete přes Google nebo přes cokoliv jiného. Tak jo, to znamená ještě jednou pro připomenutí NGINX, pokud ho chceme použít v Kubernetes pro Ingress, jsou tu dvě možnosti. NGINX Ingress Controller na rozdíl od Ingress NGINXu je F5 stále vyvíjený, stále podporovaný, pořád se rozvíjí o nový featurey a můžete ho dál používat. A v případě, že budete chtít implementovat Gateway API a dělat ten Ingress s tou novou cestou, tak je tu NGINX Gateway Fabric. Pokryje to všechny potřeby, které byste v Kubernetes mohli mít. To je asi jasný. Ještě jedna věc, jenom taková zmínka, je o tom, že Kubernetes se dneska používá jako v podstatě operační systém a běží v tom spousta věcí, můžou v tom běžet AI workloady. A ten NGINX Gateway Fabric je připravený i na to a může vám pomoct routovat trafik do AI workloadů pro nějaký, ať už pro učení nebo pro nějaké další využívání. A jedna věc, která je jakoby poměrně důležitá ve chvíli, kdy něco takového používáme, a teď už spíš jako v enterprise prostředí, když řeknu, tak k tomu budeme chtít nějaké věci a ty věci, abych to taky zmínil, tak můžou být v NGINX One konzoli. A v podstatě v dnešní době, když si budete chtít koupit NGINX Plus, tak si to kupuje jako subskripce tady k tomu NGINXu. A já to jenom zmíním, protože si myslím, že to stojí za to a se na to minimálně aspoň podívat jako variantu k tomu open sourceu, kde vy potom máte jako možnost mít v podstatě k NGINXu takový místo centrální správy, ať už je to teda cloudová konzole v NGINX One, anebo Instance Manager, který vám to potom dokáže všechno dělat lokálně. A co to přinese? Přinese to nějakou rozšířenou observabilitu. A samozřejmě ten hlavní důvod, proč si někdo kupuje NGINX, který si může stáhnout jako open source, tak bývá to, že k tomu chce nějaký support toho výrobce, takže to je asi jako reálně ten největší přínos ve chvíli, kdy to chcete používat v nějakým korporátním prostředí nebo někde ve státní správě, tak tomu většinou potřebujete ten support, aby to bylo jako pokrytý, takže to bude ten hlavní důvod. Nicméně, co tady teda je, tak je tam nějaký lepší role-based access control přímo do toho NGINXu a rozšíření nějakého monitoringu a observability. Vavka. Jedna z nejdůležitějších a nejzajímavějších věcí. A bude samozřejmě webový aplikační firewall, ochrana těch aplikací, na který ten NGINX ten trafik posílá. Vavka se dá přidat i do toho open sourceového NGINXu. Nicméně jedna věc, která je velmi zajímavá hlavně pro lidi, kteří tu Vavku potom musí ladit. NGINX jako takovej, nebo NGINX WAF, dřív se to jmenovalo UpProtect, pořád se můžete setkat s tím názvem UpProtect, tak jsou JSONové politiky a často, když tu vavku jako musíte ladit a musíte ji letět manuálně a většinou je to ta nejlepší varianta to ladit manuálně. A tak je dobrý, když je k tomu nějaký grafický GUIčko a to grafický GUIčko k tomu F5 teďko dodělala. Takže nějaká možnost sladění signatura a tak dále, tak je zase v tom, buď v té NGINX One konzoli, nebo v tom Instance Manageru. Takže to jsou takové rozšíření, který jsou dobrý pro ten NGINX Ingress Controller a pro ten Gateway Fabric, který můžou stát za to jakoby v té verzi plus. Tak jo, já jsem se dostal na konec toho, co mám připravený. A teď se zeptám, jestli máte nějaké dotazy. Does NGINX Gateway Fabric support MTLS between controller and gateway pods? Does it allow extensions similar to Istio's WASM plugin? Yes, it does. It does support MTLS everywhere, so between controller, gateway pods, and it does support MTLS to the clients as well. So yeah, it does support all that. And that's it. OK, tak já vám moc děkuju.
Díky ještě jednou za prezentaci a teď šup všichni na kafe a 11:25 pokračujeme. Tak. Raz, dva, tri. Výborne. Tak jo, máme tu po krátkej občerstvovacej pauzičke ďalší talk od Martina Štefanyho z TSP Data ohľadne llm-d. Tak usaďte sa a ideme na to.
Tak, ďakujem za slovo. A názov prednášky a popis bol v angličtine, ale zvyšok bude v slovenčine. Než sa ešte dostaneme k llm-d a ako state of the art orchestrácia poráža naivné škálovanie, rád by som len pár slov k TSP Data. Sme platinový partner týchto Kubernetes Community Days. Čím sa zaoberáme tak rôzne, dokonca by sa dalo až marketingovo povedať, že keď firmy nemajú kapacity alebo skúsenosti s novými IT trendami, tak naskočíme ako konzultanti a dotiahneme ich projekty k úspechu. Sa nám stáva veľmi často v rôznych oblastiach Kubernetes, DevOps a podobne. Takže táto prednáška bola označená ako pre začiatočníkov, pre beginner, začneme skutočne z gruntu a dúfam, že vás to nebude na začiatku zbytočne nudiť. V každom prípade to, čo vidíte na obrazovke, určite poznáte. Je to restové API a asi väčšina z vás sa už niekedy s restovým API hrala v nejakom curly, vegete, v postmenovi a podobne. Takže to, čo vidíme, je typický HTTP GET a je tam nejaká URL. Pokiaľ to prevolám, dostaneme naspäť typický odpoveď v JSON. Alternatívne, nie len HTTP GET, máme aj POST, kedy v rámci toho URL už posielam, v rámci tej požiadavky na URL posielam aj nejaké dáta a nejaké dáta dostanem potom naspäť. A keby sme si to chceli úplne prirovnať a spraviť takú analogiu, tak to možno znie až ako konverzácia a budeme s tým pracovať ďalej. A prečo som začínal tým restovým API, tak tu je jedna z tých prvých vecí, s ktorým keď som začínal s AI, tak ma veľmi prekvapila, pretože sa objavoval termín inferencia, ale keď sa na to pozrieme, tak vezmeme si zase curlový príkaz, máme tam nejaký URL, posielam nejaké dáta, kde mám nejaký prompt, nejaký model a toto curlové volanie na nejaký URL sa vlastne vo svete AI volá inferencia. A to je dalo by sa povedať, že až celé. To znamená, prevolám nejaký URL s nejakými dátami, dostanem odpoveď, dostanem JSON, v tom JSONu mám nejaké informácie, aký model to spracoval, dostanem informáciu o tom, dostanem tam nejaké odpovede, v choices dokonca im môžem dostať viac. Tuto vzorový prompt bol Praha je dnes a odpoveď bola krásne v češtine jedním z najväčších miest a tak dál, s nejakou limitáciou tokenov. Takže to je celé API pre AI modely. Vzniká tu však ako jedna otázka. Ak je AI inferencia restové volanie, tak kde vezmeme endpoint? Na to máme samozrejme niekoľko možností. To, čo som ukazoval v tých príkladoch, tak je OpenAI API, ktoré sa dneska stalo de facto štandardom, takže typicky, pokiaľ chcete OpenAI API, môžete ísť priamo do verejných cloudových poskytovateľov, buď k samotnému OpenAI, prípadne aj tá ostatná konkurencia, Google, Anthropic a ďalší, majú svoje API kompatibilné s týmto OpenAI API. Zaregistrujete sa, zadáte platobnú kartu, dostanete API kľúč a následne už pracujete s API a platíte za token. Tá druhá alternatíva môže byť zaujímavejšia. Sme na Kubernetes, tak to je self-hosting na nejakej on-premises platforme a či už je to priamo spustenie nejakého engineu, alebo je to v Dockri, v podmenovi na Kubernetes. Po výsledku máte možnosť mať rovnaké OpenAI API, ktoré je kompatibilné, ktoré zvláda podobné volania. A jedna z tých možností, jeden z tých najpopulárnejších engineov, runtimeov je VLLM, o ktorom sa budeme baviť i na ďalších slajdoch. Samozrejme, ako náhle sa pustím do nejakého self-hostingu, do hostovania v on-premu, tak až to narastie nad nejakú jednu inštanciu, tak začínajú veľmi zaujímavé problémy so škálovaním. Takže ako potom škálovať VLLM na viacero inštancií. Keby sme sa chceli ešte pozrieť celkovo, čo potrebujem na self-hosting nejakých veľkých jazykových modelov, takých LLM, tak potrebujem 3 veci. Za prvé potrebujem model. Ten dneska, hlavne open sourceové modely, je dnes možné získať hlavne na Hugging Face, čo je taký veľký repozitár open sourceových modelov. Od tých najmenších, ktoré potenciálne môžu bežať aj niekde na Raspberry Pi, až po tie najväčšie, ktoré vyžadujú niekoľko grafických kariet. A tí, čo poznáte Docker Hub alebo na kontajnery a GitHub na zdrojové kódy, tak Hugging Face je to miesto pre AI modely. A ako druhé, potrebujem runtime, potrebujem ten engine, ktorý tento AI model načíta a na druhú stranu mi sprístupní to OpenAI kompatibilné API, prípadne iné API. A za tretie, to, čo potrebujem, pretože mám model, mám ten runtime, ale potrebujem niekde prebiehali tie výpočty a to je akcelerátor. Dneska je to najtypickejšie nejaká grafická karta, nejaké GPU od NVIDIA, ale alternatívne tých možností je tam viac. Môže to byť Instinct od AMD, TPUčko od Google a ešte novšie, alebo iné AI akcelerátory. Takže ako náhle sa to vyskladám v rámci self-hostingu, mám svoj vlastný self-hosted AI stack a na jednom stroji to bude fungovať výborne, ale teraz otázka, ako to škálovať. A ešte k tomu API a k samotnej inferencii je dobre si povedať, čo to vlastne inferencia je ako low level a aký proces sa deje na pozadí. To znamená, ja keď prevolám API, pošlem nejaký prompt jazykovému modelu, a to je jedno akému, či je self-hosted alebo cloudovému, tak na pozadí prebieha nejaký výpočet. Ten výpočet ako taký má 2 fázy. A v tej prvej časti, ktorá sa nazýva prefill. Anglicky túto časť nemám preloženú, stavíme u prefill, takže dochádza k spracovaniu promptu. To znamená, celý prompt sa spracuje naraz, spracujú sa všetky vstupné tokeny a je to výpočtovo náročná úloha, využíva sa vlastne celý výpočetný výkon GPU, to znamená, rozhoduje, koľko flops má vaše GPUčko. A v tom momente dochádza k vytvoreniu tzv. KV cache, to znamená, počíta sa pozornosť, počíta sa tzv. Attention. A čo je špecifické, tak táto fáza vlastne prebieha iba raz. To znamená, odošlem prompt, dojde k výpočtu a tým vytvorí sa KV cache a je hotovo. Tá druhá fáza, tá sa nazýva decode, je to generovanie vlastne odpovede, to znamená z tej vytvorenej KV cache, z tej vytvorenej pozornosti sekvenčne dochádza k generovaniu tokenu za tokenom s tým, že táto voľa je samozrejme menej paralelná, naopak je náročná, má veľké pamäťové nároky a opakuje sa vlastne sekvenčne až do dokončenia, až do dosiahnutia maximálneho počtu tokenov v danej odpovedi. To znamená, z toho môžeme tak nejak usúdiť, že sú to 2 rôzne fázy s 2 rôznymi výkonnostnými charakteristikami a v momente, keď to budem celé spúšťať na tom istom GPUčku, tak vlastne tieto 2 charakteristiky budú zápasiť proti sebe, čo má akoby zásadný dopad potom na celkové škálovanie. U toho škálovania samozrejme ponúka sa, chcem škálovať, mám Kubernetes, poznám Kubernetes, Horizontal pod Autoscaler funguje výborne pre webové služby, tak môžeme skúsiť VLLM nasadiť a škálovať pomocou HPA. U HPA, u Horizontal pod Autoscaleru samozrejme sledujem metriku, ako náhle prekročí nejaký threshold, pridám ďalšiu repliku, ako náhle metrika spadne po threshold, repliku odoberiem. Funguje výborne, ale problém je v tom, že VLLM saturuje GPUčko, nie procesor. Takže ponúka sa možnosť, dobre, tak podľa GPU, ale u toho GPU, dneska vieme, že GPU hardware je drahý, cieľom je utilizovať ho na maximálnej možnej miere. Takže tých 80%, 100% vyťaženia GPU môže byť úplne v poriadku a bude ťažko rozoznávať, či je GPU preťažené, alebo len funguje na 100% výkonu, tak ako očakávam. Ďalší možnosť, ako škálovať, by mohlo byť podľa response time, prípadne podľa počtu requestov, ale tam opäť narážame na ten problém, že HPA je reaktívne. Takže než prekročí nejaká metrika, než dôjde k rozhodnutí, že je potreba škálovať, než dôjde k naplánovaniu nového podu, novej repliky, spusteniu, než sa natiahne celý model a že tie najväčšie modely trvajú kľudne 3 až 5 minút, než sa načítajú a užívateľia medzi tým už sú možno dávno niekde inde. Takže to je horizontal pod autoscaler. Keď to takto rozoberieme, tak na pozadí sa objaví ešte jeden zásadný problém a to je to, že tie VLM pody takto samotné, ak by ich bolo vo väčšom počte, tak nezdieľajú tú KV cache. Ako som hovoril, každý prompt potrebuje vypočať nejaké attention, potrebuje informácie v KV cache a akmile budem náhodne rozhadzovať a prompt by skončil na novom pode, tak musí dojsť opäť kompletnému. Tak tá KV cache je prázdna a musí znova dojsť k výpočtu celej tej KV cache. Takže naivné škálovanie v zmysle nahodím na to čo najviac GPUček a nahodím na to čo najviac podov, tak pre LLM úplne fungovať nebude. Tak, nastupuje na scénu llm-d, distribuovaná inferencia pre Kubernetes. Toto je nový projekt, je open source, vznikol len minulý rok v máji. Stojí za ním Red Hat, Google, IBM, NVIDIA a Corvair. A tento rok bol darovaný do CNCF ako sandbox projekt. A keď si to vezmeme, také porovnanie, typicky Linux máme ten výpočetný výkon, Kubernetes je ten distribuovaný scheduler, alebo ten scheduler, ktorý nám rozhodí workloads na jednotlivé nody, tak veľmi podobne funguje llm-d vo vzťahu k VLM. VLM je ten engine, ktorý ten model spustí a počíta a odpovedá na prompty. To llm-d je ten inteligentný orchestrátor, ktorý rozhodne, kam čo patrí. Čo sa týka tých kľúčových inovácií, tak llm-d prináša niekoľko. Ja spomeniem 3 také najzásadnejšie, čo je decode and prefill, to je nejaká segregácia týchto dvoch fází, endpoint picker v rámci nejakého inteligentného plánovania a nakoniec práve inteligentný management tej key value cache, ktorý súvisí s tým, aby nedochádzalo neustále k opakovaným výpočtom. V princípe vlastne spomeniem ešte 4. llm-d prináša niečo, čo sa volá valid paths. O tých bude neskôrší slide. To znamená, keď si vezmete rozdelenie na dve fázy prefill a decode a tú inováciu toho rozdelenia, tak GPUčka a pody môžeme rozdeliť na 2 púly, na prefill a decode. Sú to dedikované pody, každý škáluje zvlášť, môžu fungovať v iných počtoch, zaoberajú sa inou fázou a iným typom workloadu. Dokonca môžem optimalizovať aj hardware, ktorý zvolím pre prefill a pre decode. Prefill je náročný na flopsy, u toho decode môže rozhodovať väčší objem pamäte. Čo je dôležité, medzi prefill a decode potrebujem nejakým spôsobom prenášať tú KV cache. llm-d tento problém rieši pomocou externej knižnice Nixel od NVIDIA, ktorá práve zabezpečuje to, že v momente, keď prefill spočítal KV cache a attention, tak následne pre neskôršiu fázu decode môže dôjsť k prenosu na decode a ten začne generovať odpoveď. Tým sa razantne zvyšuje priepustnosť pri vysokej konkurencii. Tak, aby ten obrázok bol ešte kompletný a nebolo to len o tej segregácii, tak llm-d si sebou prináša ešte aj Inference Gateway, respektíve Endpoint Picker, ktorý sa výborne integruje s Gateway API a funguje ako taký inteligentný load balancer. To znamená, nerozhadzujem round robin v režime jeden prompt 1, 2, 3, 4, ale Endpoint Pickera vlastne inteligentne sleduje, kde existuje aká cache, kde boli spracované aké prompty a následne dokáže významne zlepšovať to, aby dochádzalo k vyšším cache hitom v rámci tých promptov. Zároveň rozumie aj typom záťaže, to znamená, či je to nejaké spracovanie ragu, nejaký reasoning, bežný completion prompt a podobne. Takže aby nebolo to škálovanie o tom nahodiť na to čo najviac GPU, ale použiť ten existujúci hardware, ktorý je dostupný a použiť ho inteligentnejšie. A ako som spomínal, llm-d prináša ešte jednu vec, čo sú tzv. Well-lit paths. To sú príručky pre nejaké konkrétne use casey, to znamená, pokiaľ budem riešiť práve inteligentné smerovanie a podobne, tak je tam príručka na túto konkrétnu oblasť, prípadne tá pokročilá správa KV cache. Takže u KV cache čas môže existovať v rámci pamäte GPU, čas sa dá offloadovať na systémovú RAM, prípadne zbytok až na NVMe disky. V rámci tej segregácie a toho rozdelenia, tak llm-d vie dobre pracovať aj s najpokročilejšími modelami, ktoré sú tzv. Mixture of experts, to znamená pre veľký paralelizmus, tak aj na túto časť je tam príručka. Tak, v rámci prednášky, práve aby to bolo trošku zaujímavé, tak som si pripravil demo. Znamená, porovnáme si, ako vyzerá, keď dochádza iba k najvému škálovaniu. Znamená, v rámci modelového príkladu je to VLM v 4 replikách, s tým, že je tam iba štandardná cluster IP servisa v rámci Kubernetes, voči týmto 4 replikám pobeží 5-minútový guide LLM benchmark a bude nás zaujímať kľúčový indikátor, a to je vlastne čas do získania prvého tokenu v sekundách a ešte k tomu 95% percentil. Tak, snad zafunguje video. Jo, super. Takže vytvoríme si Inference službu, počkáme na pody, nabehnú všetky 4 repliky. Následne si vytvoríme službu, ktorá v štandardnom round robin režime bude rozsadzovať API volania a prompty na 4 repliky. To je len ukážka toho Guide LLM frameworku. Pobeží v 2 konkurenciách na 32 a 64 súbežných streamov. Spustíme si benchmark. Benchmark má nejakých 5 minút, kým pobeží. Medzi tým v grafane môžeme sledovať. Vlastne vľavo je vidieť, utilizácia KV cache je nízka, okolo 40-40%. Ten time to first token na začiatku nejakých 20 sekúnd, v našom prípade neskôr to naskočí na 40. Naopak vpravo je vidieť, že tie GPU cache sú koľkokrát utilizované vysoko na 90% a intertoken latencia niekde okolo 400 milisekúnd v tých najhorších prípadoch. Dokončení ten finálne číslo nejakých 20 sekúnd v našom prípade. To znamená, to je nejaká baseline v tom naivnom škálovaní. A oproti tomu posadíme llm-d, znamená rovnaké 4 repliky, ale tentokrát sa do cesty medzi obsluhovanie toho API a VLM sadí cez Inference Gateway nejaká prefix aware cache alebo cache aware routing, to znamená, ten už nejakým spôsobom sleduje, aké prompty sú posielané na to API a dokáže robiť nejaké inteligentné rozhodovanie, na ktorú repliku poslať to volanie. Pobeží opäť rovnaký 300-sekundový llm benchmark a budeme sledovať rovnaký kľúčový indikátor, to znamená 95% toho času na prvý token. Tak, tu je to trošku zložitejšie, pretože dochádza k integrácii cez Gateway API z Kubernetes, to znamená, potrebujeme Gateway class, potrebujeme Gateway samotnú, nie iba obyčajnú servis, následne definujeme, ešte definícia, tak vydefinujeme Inference Service, to znamená v rovnaké 4 repliky, každý pod jedno GPUčko, 4 CPUčka, 8 GB pamäti, aby to bolo identické. A následne úplne rovnaký guide LLM benchmark, ktorý pobeží zase rovnaká konkurencia 32, 64 po dobu 5 minút. Jo. Toto dáme ešte obohatené, že je tu priamo akoby skúška krolom pre volanie toho API s nejakým promptom. Tak, už nám bude štartovať guide LLM benchmark. Tak, keď sa pozrieme do grafany, tak tie grafy vyzerajú úplne inak. Utilizácia cache nie je 40-50%, ale krásne nad 80%. Ten čas na prvý token sa skrátil z tých 20-40 sekúnd v najhoršom prípade na nejakých 5. A naopak utilizácia tých GPU cache je nižšia, pretože dosť veľa informácií, dosť veľa cache sa čerpá práve tým transferom. A reálne intertoken latencia tiež spadla, myslím, z nejakých 400 na 100 milisekúnd v najhoršom prípade. Takže finálne číslo je nižšie. Čo je zaujímavé, keď si to porovnáme, tie dva prípady čistého naivného VLLM versus llm-d, tak vlastne s narastajúcou konkurenciou, to znamená u toho prípadu 3264, tak u toho 64 ten aj najhorší prípad toho času do prvého tokenu bol, ten skok je tam ako markantný. A u toho 32 nie je tak vidieť, je to zhruba polovica, ale u tej vyššej paralizácie, kde tá prefix aware routing má viac príležitostí inteligentne rozhodiť tie requesty podľa predchádzajúcich a podľa stavu cache, tak tam je ten čas zásadne kratší a response time je tam lepší. Tak. Zhrnutie len v krátkosti. AI inferencia, vlastne iba obyčajné restapy volanie nejakého AI modelu v rámci snah naivne škálovať na Kubernetes pomocou horizontal pod autoscalerov, tak pre LLM workloady to úplne fungovať nebude. Preto máme llm-d, ktorý to rieši práve ako pomocou niekoľkých inovácií, buď v rámci jednak disagregáciou fastých inferencie, inteligentným routingom a managementom KV cache, presunom medzi rôznymi skupinami workerov a llm-d open source, dneska CNCF Sandbox projekt. A asi dodám, že už dnes je súčasťou OpenShift AI 3, takže tí zákazníci, ktorí máte OpenShift tak AI, tak možno už llm-d je pre vás dnes dostupné. Tak. Ďakujem za pozornosť. Asi to bylo časovo efektívne. Nie. Aktuálne porovnanie s KEDou nemám. Takže nemôžem odpovedať. Nie. Porovnanie s KEDou nemám, ale KEDa podobne ako HPA takisto reaguje na nejakú metriku, aj keď tá metrika môže byť špecifickejšia, nielen nejaké vyťaženie CPU, GPU a podobne, ale opäť je to ako podobný problém tej reaktivity. Super, ďakujem.
1, 2. Okay. Okay, so let's continue with the next talk with our fellow KCD organizer from Provence, Donia, from Isovalent / Cisco right now. And the topic will be what happens when eBPF meets the GPU. So the stage is yours.
Thank you. Hey everyone, can you hear me well like that? Yeah, okay, cool. Okay. Ohaj Praho. Ahoj Praho. Is it right? Okay, cool. Learned that in the planning yesterday. So, hi, I'm Donia, and I'm a software engineer at Isovalent. I'm also part of the community team. At Isovalent, yes, we've been acquired by Cisco. We are doing open source products around networking and using eBPF. I'm also a KCD Provence organizer, and our CFP is open, so doing a little bit of promo if you want to come in the south of France in December, and it's sunny, I promise you. So we're going to talk today about eBPF and how eBPF is meeting the GPU and observability. So I want to do a quick GPU 101 because before preparing this talk, I just didn't know much about it, and I feel like maybe you're going to be interested to understand more what's inside. And what is eBPF for the people that are not familiar with? Where is the observability gap today? And a little landscape of what eBPF tools can offer today about GPU observability. So I would just wonder how many people are on call sometimes in this room. There are a few. That's interesting. Do you manage some GPU? Oh, yeah, there is a hand. OK, 2 hands. OK, go high, guys. 3, OK, that's cool. That's very interesting. I feel that's still very niche, but it's definitely expanding. So do you have like dashboards today where you can see what's happening on the GPU for the 3 guys? Yeah, you have. OK, interesting. Let's talk about it after. And it's a no over there. OK. So this is just a very, very basic screenshot to show that we have, yeah. Oh. Oh, your pardon. Don't worry. Thank you. So you have a very basic like screenshot of what a basic GPU dashboard can show, and it's most of the time very basic information, and we want to go deeper. So let's go into AI infrastructure stack. Don't be overwhelmed. We're going to go step by step here. So we have an application. Most of the time it's Python today, and we are running model forward and data loading in this Python application. Then it goes to ML framework. Can you see my cursor here? So I can show you. OK. So we have an ML framework. Usually it's PyTorch, but there are a bunch of them. And then we have the GPU runtime API that computes API, and we have the driver libraries. We're going to talk more about CUDA today in NVIDIA, because I got a distant access to a GPU from a friend. Thank you so much to Alex. And then we have the kernel space, and inside we have all the syscall functions, like network access, memory management, network I/O file system, all of that. That is running on your machine. And we have the GPU driver then that is doing the command submissions to the GPU device. The GPU device is plugged to the CPU thanks to, here I took the example of a PCI Express, but it can be other transport. And we have the GPU device that has 3 different boxes here. So the first one is the VRAM. Basically, it's storing all the gradients, all the mathematical stuff that are needing. And a KV cache, a key value cache that is going to be interesting after. We're going to talk about it. We have the compute units doing the actual compute, the core. And we have the GPU kernel exec. And here, this is the kernel for the GPU, and it's doing the math operation, all the instructions that are transformed, and some parallel execution. So yeah, doing like the main job, I guess. And I want to touch about what AI infrastructure can do, because yes, we have hardware, but what can we do with it? We can do training or inference, some buzzwords. So let's just dive a little bit what it is, actually. So AI workloads are using training workflow to build a model. So you're going to train a bunch of data. First step is to load this data. And then you're gonna go through a step called forward pass. It's just run the input model and run the input and go through the model to get predictions. And the third one is compute loss. So basically it's gonna say, is it a dog or a cat? And it's gonna compare to the correct answer. Of course, the correct answer has been labeled by someone in the word. So I just want to raise awareness around that. Fourth, the backward pass is the calculate gradients, which tell you how to adjust the weight. Basically, it's math. We're back at the university, but definitely gradients and doing some computation. Finally, we have, not finally, sorry, but we have an SSL step, which is all reduced. Basically, if you have different GPUs, it's going to synchronize the different gradients. So at the end, you have the same answer between the different GPU. All agreed that it's a dog or it's a cat. And that's what's happening here with numbers. Finally, we have an optimization step. And now the GPU are all agreed, and your model is trained, and you're storing all this information that are going to be used each time you want to do inference. Because inference is about serving the predictions that we've been trained to in real time. So you're a user who is not using LLM today. Yeah, I guess everyone. So you're going to write to a prompt. Here, I say, write me a poem. Because we just don't only code. We do other stuff. And we're going to load this input in the model. And it's going to be tokenized. So in different words sometimes, like one word is a token. Then we have a prefill step. And it's going to generate the KV cache we've been talking about. So associating one word you put in the prompt to something very more, again, mathematical, to a matrix, a value. Then you're going to decode each time, like for each token in an iteration, and you're going to check in the end for all these tokens, what is the answer from the model. And at the end, the tokenize is just taking all these gradients and making it human readable for you as developer, so you understand what your prompt is telling you. So maybe you generated a bunch of tokens because you've been just talking to it like a human, so you don't care really about the words you're using. So you're going to fill your KV cache in the end really fast. So maybe we have bottlenecks here. Maybe we need to observe that kind of things and that kind of behavior. And here is just a summary of the different bottlenecks that you can observe. So on the training side, we have the computation. It can be on the communication side. You can fill up the memory with the VRAM. You can have I/O problem if you're loading too many data because your GPU is not able to handle that. And on the inference, we have, again, memory bandwidth with reading the KV cache. It can be on the decode side because you can't parallelize all the tokens when you are decoding them. VRAM capacity or prefill latency. So that's just a summary. It's more as a reference, so you understand that it can be a bunch of bottlenecks in this workflow. And what are the tools that we have today? We are not really able to see GPU kernel execution, and on the diagram, it was all like the left box. Like the memory transfers, all of that is kind of blurry at the moment, and we are building, I guess, these tools and going through that way. But there are some vendor profilers tools, like NVIDIA eCubT, but they have a huge overhead at the moment. And you have to run a profiling session and analyze results offline, which is a bit annoying because we want to have live stuff most of the time and to see what's happening and alerts and whatever. So yeah. I like just a little bit. There is one tool that I didn't really explore, but I know it's existing. It's not based on eBPF. It's a GFX vendor from Intel, and it's like a top, and you can have some information. So, as mentioned, there are a bunch of tools. All the green boxes are just tools that exist today that are not eBPF based for most of them. And on the GPU device side, we have like kind of a black box today. And I called it the visibility wall. So let's see how we can dive into this wall. And to talk about that, we're going to talk about eBPF. Who is familiar with eBPF here in this room? There are quite a few hands. OK, please bear with me. So eBPF is like a Swiss Army knife for the Linux kernel. It lets us run custom programs inside the kernel, and these programs can observe, modify, or act on kernel events like networking, file access, tracing, without needing to modify the kernel itself. And without eBPF, if you want to make changes in the Linux kernel, you have to submit a PR to Linus Torvald, and then it has to get approved, and then it's going to take years before it's going to be in the distro. So that can be a very cumbersome process. You can also run kernel modules, but it can be very risky because of the stability. So with eBPF, that's just easier. You can run dynamically programs and load them without modifying the kernel source code itself. And it provides a safe and sandboxes environment for custom logic. You don't have actually to be afraid of running eBPF programs that are going to crash your kernel. It's not going to happen. So let's see how it works, just a little bit. You have the user space, and you have the Linux kernel space, the kernel space, and your app is running in the user space. Then you want to hook to an event. So the eBPF program is going to hook to trace points, kprobs from the kernel, uprobs to the user side, traffic control to see networking, or express data path, which is a component before the CPU. And it's safe because you have a verifier that is making sure that you have no infinite loops, memory safety, kernel integrity, and in the end, it should be approved before going through the compiler. Then it's compiled, and the eBPF program is actually attached to your kernel. So it's interesting also for Kubernetes. I mean, we are at the KCD, so I'm going to talk a little bit of Kubernetes. So the pods are running on the user space, and the eBPF program, again, is on the host. So what's happening is that eBPF is going to have a visibility on the entire stack, on all your pods, with only one program. So again, that's very powerful for maintainability, for example, or debugging. So you can observe everything, and it's not limited to individual containers. And there are a bunch of tools out there, like BCC for tracing, Pixie for observability, Cilium that I'm working on for Kubernetes networking. So they're all based on eBPF, and there are a bunch of SDKs with different languages. I'm a Go fan, but whatever. So let's talk about GPU and eBPF now. I want to present to you different tools that exist in the ecosystem. Note that most of them emerging, but there are some production-ready ones. And I want to do just a shout-out to all the academic papers that have been done, because this is at the heart of what's happening in the eBPF world. So we're going to talk about runtime observability, where we can trace CUDA API, the GPU runtime library. We're going to talk about inference-aware observability, when you have a LLM request, and then from the user prompt, how it goes to a final token that is generated. And about infrastructure correlation, like Kasper said it this morning, like you have a lot of metrics, but how can you put a context and understand what's happening? So let's talk about the first layer. I'm going to present to you a tool called GPU Prob. It has been written by a computer science student. I would have not been able to write such a tool when I was a computer science student, to be honest. But what is it doing is that it detects things like memory leaks, kernel launch patterns at runtime, and exposes some metrics that you can then put into a Grafana dashboard. So that's very user-friendly. And then you ask your AI agent to do it as a SRE, of course. So one person asked him on Reddit, like, how it is compared to, so for example, the NVIDIA tool. And his answer is that it provides debugging and profiling live and metrics live without any overhead, because eBPF is not adding any overhead compared to tools that are using like other languages. And what is happening, it's using eBPF on the CPU side, back on that diagram. We're going to see it often. Get familiar with it. So it tells us, like, nothing with traditional tools about like CUDA runtime latency or more like very deep information. And here eBPF is used to probe two different aspects. So I just put a sample of this diagram to show you like, oh, you can't see. That's funny. Why is this out? Okay. So I don't know if you can see properly here, but basically it's a bunch of functions from the CUDA API library that are available in the kernel that you can just probe exactly at this point, and then you can observe them. And on the kernel itself, on the syscall, you have different functions also you can probe. For example, sched switch, and you can see when the scheduler of your CPU is switching to access to the GPU, so you can measure all the GPU access. So if it's switching too much, maybe you're gonna do some optimization on the way you're doing your tokenizing, for example, or whatever. So how does it work? GPU probe is using some different functions that are available from CUDA to see that. So we have one that is QLaunch kernel. Again, it's to see each time the GPU kernel is accessed to. And the CUDA memory copy is enabling to see all the transfer data that are done between the CPU and the GPU. And then you have like output like that. If you're not familiar with eBPF, BPF trace here is just a tool to probe to Linux kernel events. And we're gonna do a little demo. Hopefully it's gonna work. Let's pray the demo god. Okay, this is so the GPU, this is a machine that I have access to, and there is a GPU running. This is an NVIDIA one. It's running Windows, which is interesting because eBPF runs mostly on Linux. So I'm running Windows for Linux. I didn't do that since a long time, but yeah. So I can do some things, but there are something that are actually mocked up. So I can't have access, for example, to the kernel launch with eBPF. So I'm going to show you some limited function, but just wanted to show you. So here I have two programs. The first one is CUDA trace, BPF trace, and what I'm going to do is not P, but B. BPF trace on the CUDA trace.bt, and I'm attaching two props. So I'm going to attach to the memory allocation function to show you what we can do. And on this side, okay, I'm going to do a Python program that is going to run some stuff. So you can see here at the bottom, we have some function that are run and doing some allocation. And at the top, we can see the trace from eBPF. So each time there is an allocation that is done on the GPU, we can have a trace of what's happening with the PID of the function that has been called. Here's the process is Python 3. And the time, like when it was, you can also measure how long it takes. So it's just a simple, tiny thing to just show you with simple, like just simple lines of code what we can do. So let's go back to the slide. And we're going to talk about the layer 2, about inference. And I want to present to you today eInfer, which is a tool that is correlating LLM inference with GPU activity. So what we have, again, this diagram. So we have an inference server. Can I show that? Yeah. We have an inference server here, and we have uprops at this level. So at the very beginning of the workflow, we're going to be able to trace, for example, if you're running VLM engine, the queue time of your request, how long it is taking, how much time your requests are queued. So maybe you're going to increase the number of GPU you are running. And in the world of Kubernetes, probably you're going to scale somewhere, scale out the number of GPU you have. On the GPU runtime API, we have the same function as before, memory allocation, the copy that you can have, and on the kernel side also. And on the ML framework, we have also very interesting. So do you remember like the inference workflow I showed you? So on each step, you're gonna be able to measure what's happening and observe the time it's gonna take, again, like the memory of the KV cache, for example. So you're gonna be able to profile very deeply what's happening when you are launching a request. And how to use it? Again, that's a CLI. So it's very easy to plug into an agent AI, I guess, and just have an answer of the request for a request for the queue, the prefill, the decode step, all the stuff we've been talking about. And you can spot the bottlenecks, for example, here on the second token. I don't know what happened, like for the second batch, something was wrong. So you're gonna be able to observe deeply what was happening for this one. I'm going to show you another demo, just for the fun, of what we can do with eBPF. So let's kill that. And okay. I'm in demo 1. Let's go to demo 2. And here I'm going to do, again, a sudo BPF trace on the CUDA. And here I'm tracing the memory copy between the CPU and the GPU. And on this side, I'm gonna launch a Python, what's the name? GPU test 2. And what it is doing here, so again, it's a very small program, but, oh, am I launching the same thing? Oh, yeah. I was like, oh, is it the same thing? No, it's not. Oh, no, the output was good, but that's not what I wanted to show you. That's interesting. OK. Oh, yeah, that's the one. OK, so here I'm allocating GPU tensors, memories with different sizes. So I have a small tensor, a medium, and a large one. I'm doing some computation of matrix using matmul function for the ones who knows. And what is this interesting? So let's start here. We have the memory copy that is async between the CPU and the GPU, the hosted and GPU here. And we have the allocation that we saw just before. So we are just adding more props to what we can observe. And again, this is a very sample of what we can do. On all the function. I really wanted to show the with pod and PID of pods, but with Windows for Linux, that was a mess with namespace PID. So, but you can do stuff with pods, which is interesting too. So that was the demo for the memory transfer. And I put together a remediation guide that's very high level. I will not go into details, that's more for reference, but I will share the slides, of course, but it's just to see, at each step, you can have a bottleneck and how you can mitigate it today as a SRE or DevOps or an agent AI. And so to finish, I want to talk about, not to finish, I have a bunch of things to say, and I'm late. So infrastructure correlation, it's about what you can correlate or not between all the context that you have, and as mentioned for the pods, which pod owns the GPU, which request caused the spike, and all these questions you're gonna ask yourself if you're on call, and everything is just messing up at 3 a.m. And eBPF here is just bringing on the table with these new tools correlation between what's happening on the CPU, on the processes, and what can happen really on the GPU side. And this tool I wanted to present very quickly. This is EACGM. I'm not going to read everything because that's very long, but it correlates GPU metrics with infrastructure signals. And again, there is eBPF running everywhere, different programs hooking. And what they do in the end, which is interesting, I think, is that you're going to be able to correlate all the layers that we just show here. This is from their GitHub, so you know. All these layers into something that is understandable as a mathematical or data analyst human, probably, but just to understand multi-layers information and metrics about what's happening on your GPU side. How do you use it? Again, that's a CLI tool, which is very powerful. Again, because you can just run it in any workflow as a DevOps. Some remediation guy, like what are you doing if you have too many CUDA memory copy, as we saw. You can reduce the memory copies, you can tune that, for example. And what about the future vision? So as mentioned, there are a lot of research going on. If you go to a Linux Plumber conference, you're going to see that there are a lot of topics these last 2 years, actually. And there is eGPU tool that is actually injecting metrics and programs inside the GPU device. So we are breaking this visibility wall layer today through to that. And it's using PTX injection, which is GPU assembly language that is intermediate from NVIDIA. So you're going to be able to instrument directly into the GPU using that kind of tool. And they're actually working on expanding to other GPUs, not only NVIDIA's one. Yeah, it's in research stage. So the usage, again, it's a CLI, so very powerful. And you can have like different level of bottlenecks again in the GPU device side. And for different operation, you have different solution, of course. But again, that's for reference. So you can read that later. The other one I wanted to present is agent side. So I've been talking here about GPU, but and very hardware side, I feel. But we are going more and more around what agent can do for us. I tend to say that we are going to be AI agent managers and not developers anymore. And how can we observe what they are doing is also important. So agent side is one of the tools doing that. Anyway, I wanted to thank you. And so the main key takeaways today is that GPUs are infrastructure now. It's really part of the global infrastructure. Not a lot of people raised their hands today about GPU, but I feel like if I ask this question next year, we're going to have much more hands. So it's going to be interesting. eBPF observes the boundaries. So we saw the CUDA runtimes, the kernel transition, and all the things that eBPF is able to hook on. And correlation matters more than metrics. I think that's the theme today. Like, how do you have this how do you make these metrics making sense to people? And again, the ecosystem is very early, but I feel that's very interesting to see what's happening, very exciting. I can't wait to see more and more contributions to it. And if you want to shape the ecosystem or are curious about it, I feel that's a great time to be in the first-time player. I'm also part of the Merge for an initiative, and I would love to see you in the Slack channel if you're interested in. This is a diversity initiative from the CNCF, and we are running events at KubeCon, some programs, so you're more than welcome. Thank you so much. Feedback is a gift, I tend to think. So if you want to give feedback about my talk, I would love to. This is my first time doing it, so I would love to see what you think about it. And I put all the resources of the different academic papers and blog posts that I've been using to build this talk. So thank you to all the community of the open source for that. And if you're curious about eBPF, there is a lab from Isovalent company. I love the fact that you don't have to install anything on your laptop and you can just go somewhere and just get your hands dirty. So thank you. That's a very good question. I think that at the moment, you can't, but I feel that the gap to do it is not big, I think. That's just about formatting. Will llm-d default metrics got this someday? That's a very good question. I hope so. I think that I didn't talk about network here. I talk more about the GPU aspects, but definitely in inference, especially, we want to spot where are the network spikes, where are the network latencies. So it should be. I guess it depends on the clients. Is it compatible with NVLink? Yeah, it is. Okay, it depends on the tools. that you're using, but there are some tools that are compatible with NVLink transport. Will the slides be available somewhere? Definitely. I usually put my slides on speaker deck, but I will share them on my LinkedIn. So I would love to connect. My name is Donia. Is eBPF secure? Yeah, so that's why I mentioned that is eBPF safe. You can't crash your kernel. Like, all the things you can do is write programs that are going to hooks to what's happening and different functions. And you can't actually hook to something if your eBPF program is not secure, because the eBPF verifier is doing his job really good. And I know some people working on it, and they're really good. Thank you so much for your questions.
Cool.
No, it's the first time I'm doing something. When I was there. I was a bit nervous. No.
Hi everyone, welcome to today's talk titled Log Normalization, where I will be giving you a guide why you should do it, and if you aren't already, then perhaps you should give OpenTelemetry semantic conventions a go. This is also titled The Art of Providing Detection-Ready Data, which I think sounds cool. Hopefully it lives up to its name. But first, just a few sentences about myself. I'm Szilárd Parrag. I'm currently a senior software engineer at TextFlow, where we maintain security logging pipelines on steroids, I would say. So I'm also a logging operator, maintainer. It's a CNCS sandboxing project. And also, I have already contributed a few times to the OpenTelemetry collector contrib distribution. Now, to set the mood, let's imagine a scenario where it's 2 a.m. in the morning, you are digging through your logs and realize that, oh, there is some authentication failure, I have to find the reason real quick. But oh no, component A calls it USR, component B calls it user.name, and component C calls it user with a capital U, of course, for variations. Now, at 2 a.m., you're sitting and writing needlessly complex queries. And then you realize that correlation across sources is impossible without a shared vocabulary. Now, I told you what happens, and let me give you a short reason why this happens. The most important thing is that the people who write these logs are not the same people who are going to be consuming them at the end of the day or at the start of the day. Application developers primarily write these logs for debugging reasons and not for monitoring or correlation reasons. So if there's any schema, it's most likely the one the dev came up with, if there's one at all. Also, these two groups rarely discuss these types of, issues or integration plans, especially as, application developers might be likely to be third-party developers from your vendors or your company's point of view. And also, I want to describe what, in my opinion, detection-ready actually means, and I think these 4 attributions are the right way to describe it. The first is consistent field naming, and by that I mean that the source.ip field is always going to mean the same thing, and for it to be meaningful, the value must be also consistent across every single source, so that the source.ip is always going to be an IP address, not something else, a host name. So you can rely on these invariants when you write your queries, detections, or alerts. Also, when you are writing these things, you must also take into account that these semantics are consistent among all your different sources. So the user in authentication logs is the same identity in audit logs as well. So yeah, the same key means the same value across different types of signals. And the fourth, and I think that's mainly the interesting part for this talk, is the available enrichment. This allows one to express a bit more context besides the logs already. For example, giving them Kubernetes attributes, for example, the name or the node name, the namespace name, or really just anything. And by these 4 things, you can make sure that normalization turns raw noise into actionable intelligence. Now I'm going to give you 3 schemas. They try to solve the one problem, which is into which slot should I put this information. At first, we are going to have a look at OCSF, the Open Cybersecurity Schema Framework, then a look at Elastic Common Schema, and finally the OTel Semantic Conventions, which is, I think, is going to be the way forward. Really, just a quick glance, OCFS was launched in 2022 by Splunk and many other big vendors, and it's a vendor-neutral framework which has a heavy emphasis on being a security-first schema. And basically, you have class-based models everywhere, where you have a class UID, which describes, for example, for authentication type of logs, it's 3002, and for different ones, it's going to be different, of course. The pros and cons of it is that it's deeply semantic and precision engineered. I mean, this is a really well-made one, but its weakness is that Kubernetes-specific fields are not built in yet. The schema is also available for extension, but currently it doesn't have a Kubernetes native field out of the box. Now, the second one, ECS. Introduced in 2019 by Elastic, huge thanks to them, by the way, because after roughly 4 years, they decided that they want to donate this to the OpenTelemetry organization and name it semantic conventions. First, it's a flattish dot notation schema, and it's mostly battle tested in SIEM environments. And by that, it also comes with some pros and cons. The hugest pro is the huge field catalog and deep integration. The weakness is that it's elastic flavored, and non-elastic mapping is, I would say, a bit cumbersome and manual. And also, ever since they donated the schema itself, they tried to converge it towards the semantic conventions, but a true one-on-one mapping is not really possible due to conceptual differences. They also highlighted in their blog post. And now I would say the way to go is the OpenTelemetry semantic conventions, which started back in the day with metrics and traces type of signals. But nowadays, logs are also considered first-class citizens for signals. And it also gives you a really nice standardization because you have one wire format as well for your schema to come with. And because of these different types of signals, you have the same convention upheld against all these signals. You can achieve true correlation with that. The weakness is that it hasn't been adapted that widespread yet, but I encourage everyone to give it a try, especially if you haven't given any schema a try yet. Now just have a quick example. For example, I have an Alice user who is going to be logging in from a 10.0.0.5 IP address. In the ECS schema, this is how it's described. The OCFS is really similar, but I omitted a few fields because it is really verbose. And on the OTel part, it's really similar to the elastic one for the reasons I previously mentioned. And also, by using a schema for your logs, you also can help with your AI and LLM detections because you know these things really love repetition and predictability. So it also gives you a really nice leverage for the mess you might be having currently. And I just wanted to highlight that all these three schemas basically are much more similar to each other than different, so they converge more than they diverge. Now I just want to go over the following, I would say, possible debate, whether you would like to use any vendor lock-in or closed source schemas, for example, which I would say they work until you change vendors, because then your entire security infrastructure becomes a legacy debt. And as it's written in the bottom, open schemas survive vendors, proprietary schemas survive contract renewals. So I encourage everyone to give open schemas a try before relying on closed ones. Because basically you are creating a really tight coupling, the data platform and the data. And also, why am I talking about OpenTelemetry semantic convention for Kubernetes-related stuff? It's really easy, because the OpenTelemetry collector also collects Kubernetes logs, and I would say in a really nice way. And basically, just by adding a few lines of code into the YAML configuration file, you also get enrichment in every single log record you might be processing in your pipeline in a standardized Kubernetes namespace as well. I know it's release candidate at the moment, but it's stabilizing, I would say, pretty soonish, so I would consider it is almost stable. Now, you might be wondering, how the heck do I approach this? Well, the good news is that OpenTelemetry provides you many ways to achieve integration. One of them is using the native OTel software development kits available in many languages, and I don't know, listed a few: Go, Python, C#, JavaScript, Java, basically anything, I would say. And they also provide you a so-called LogsBridge API, which allows you to use your beloved framework for logging in that ecosystem you're used to, with the added benefits of also exporting it to the OpenTelemetry protocol as well. Basically, for Golang, I just created a really short pseudocode where instead of using the log/slog logging solution, you just create the same thing, but by using the OTel slog one. And by using it, you leverage the possible OpenTelemetry attributes. Meanwhile, you just don't really have to make any code changes to the old call site as well. So it's a nice one. But also, let's just say that you don't have the capacity or the ability to modify the code you are running. For example, you're an infrastructure engineer and you don't have the necessary tools to modify the source code for your applications. I hear you. For that, I give you instrumentations. They are two types of instrumentations. One is code-based, which is, of course, requires some modifications into the code. But also, there are some zero-code-based solutions as well. And you can just set some environment variables for your Python Flask application, and then, boom, you have OpenTelemetry logs coming from your Python application just by setting one environment variable. Neat, isn't it? And as a, I don't know, quote, I would say that the right place to normalize is as close to the origin as possible, because that's where you have the most of your context available, and it's the easiest one to do, because after a certain threshold of passing it away from the source, you just don't have that context anymore. Now, let's have a look at a concrete Kubernetes pipeline example. I have some application that is capable of writing OpenTelemetry logs, and the OpenTelemetry collector itself is going to collect those logs. Then in the pipeline, it's going to filter, redact, or enrich those logs, and then send to some destination that also supports OpenTelemetry. Now, my basic logging that just said that the user is Alice, and it's coming from that IP, and I don't know, the event type is logon, also has resource detection, so I know which GCP or Azure or AWS workload it comes from, but also it has Kubernetes attributes, thanks to the K8 attributes processor as well. So I have everything neatly organized and available next to the log itself, meaning that I can make really nice decisions based on that. And now a quick where should we normalize? As I previously mentioned, the easiest one to normalize, not the easiest, but I would say, best approach or the most accurate one is the source level, but sometimes it's not feasible. Then you have in the pipeline. I think that's the pragmatic middle ground, and I will dive deeper into it. Why? And in the end, you can also normalize, but I would consider that's the last resort, because at the end of the day, you are going to be creating some tightly coupled machine to that specific destination that you are currently using. And I would say it depends on the strategic placement between balance and accuracy and engineering effort. So you have to balance all these points. Now, as I've previously mentioned, I don't think that you should be normalizing at the destination side, because it creates a vendor lock-in trap, no matter how they would try to sugarcoat it. And it's all right. They have their use cases, but if you want to create a really, I would say, future-proof logging solution, then I would use the OpenTelemetry semantic conventions, and then at the end, I would use that as a source for mapping for that particular SIEM or observability tools schema. I wouldn't just rely on that. Because if you relied on it and you have created really nice dashboards, workbooks, and everything, then any change that you might be required to make and adapt to a new platform is going to be a huge trouble. So normalizing the pipeline, mapping the SIEM only when you must. Now I've already told you why I think that the most convenient way is to normalize in the pipeline. It's because the reality of apps is that you don't control every application. Legacy system emit logs in a fixed format that cannot be changed at that point of origin. Now, at the pipeline, you have the ability to make changes to it, and you also have the sender source, the sender's IP, for example, and you have the context required to do so, because if you have done this thing at the end of it, you might have not the same sender's address than previously. And basically, by implementing this normalize once and fan-out mechanism, you also get the benefit that you can, I would say, much easily can swap your backends and your destinations instead of just being tightly coupled to them. So the OpenTelemetry transform processor enables the normalized ones and fan out everywhere. And one more consideration to, I don't know, give you an incentive is the storage and cost considerations, because if you have a nice schema, then, everything looks really similar. It might be also possible that it compresses much better. And yes, it does. By repeating everything in the schema, the top-level keywords and everything, it compresses much better compared to a free-form log format, for example. And also it's true for storing it in your backend and also when it goes through your wire and network. Now, let me give you a short introduction to the schema's extensibility. Every schema that I've previously mentioned provides you a way to escape hatch principle, I would say, to add custom attributes and custom fields to it. For ECS, you can use the labels. For OCF, you can write your own extensions as well. Or for OTel, you can write attributes. Seems easy enough, but most importantly, please never overwrite reserved keywords. It's not a good idea. It never was. And make sure that you have somewhat namespaced attributes for your use cases. And for that use case, I would suggest giving OpenTelemetry Weaver a try. It's a really nice, side project of the OpenTelemetry as a whole infrastructure, which basically allows you to write your own schema and integrate it with the core schema itself, giving you validation, comparison, code generation. And I think the neatest thing is that also gives you live checking ability, meaning that once you have written your normalization, you can check it whether the logs currently emitted by your applications conform to the schemas you just want to uphold. And I just want to give a minor shout out to tomorrow's talk titled OpenTelemetry Playtime is Over, because currently I'm giving you the why you should be using, for example, OpenTelemetry Weaver, and I think they will be giving you the how part. So hopefully we see each other at that talk. Also, if you normalized and everything is available in the standardized format, you can also use that for your metrics. For example, now that I have a specific field to store the user.name field and its value, I can create authentication failure rate based on that information, for example, for each namespace I might have. Or I just can create a really nice 95 percentile request size for each service name I might have. The same is true for egress bytes, for example, for a namespace in Kubernetes in a multi-tenant environment. And I want to give a minor shout out as well to my colleagues' previous talk titled Counting What You Care About. It was a really nice one, I would say. And by leveraging these normalized formats of logs, the logs become a metric source out of the box because dimensions are already standardized. Now, for example, let's just say in a Kubernetes environment, what are those values? It's just a really short list. And I suggest everyone to give a try and reading of the OpenTelemetry Semantic Conventions Kubernetes attributes part, because it's a massive list. And I would say anything that might be relevant is present here. So the pod name, the deployment, the namespace, the node, the cluster, the persistent volume claim, the persistent volume itself, the UIDs, everything is there. So feel free to use them because it's going to be available next to your log records. Now, you might be wondering what you should be doing, as everything looks really nice, and you might be thinking that I'm trying to hype you up for a hype train, and I might say that it's kind of true, but let me give you another perspective, I would say. For instance, I just suggest you give any schema a try, and then if you haven't tried any schema yet, then OpenTelemetry Semantic Conventions might be the one to choose. Normalizing the pipeline, not in the destination, as I've previously discussed. Use the OpenTelemetry Semantic Conventions and OTLP protocol as your default. and use the schema's extension mechanism for custom fields. Never invent top-level keys. That doesn't go well down the road. And also treat your scheme as an infrastructure, versioning and reviewing changes. It's really important as consistency is earned through pipeline-level discipline. And you might be saying that, oh yeah, it sounds great and everything, but it might be a hype train. And let me rephrase that. Currently, around 300 or so vendors are behind OpenTelemetry and adopted it or provide some support for it. For example, just to name a few, the AWS, Elastic, Azure, Grafana, Google Cloud, to give you a few big names. They all implemented it, and they all support log ingestion through OTLP. And they are all OTLP native. The semantic conventions also gives you common names for common concepts, such as HTTP, database operations, or operating system changes as well. And by that, you can also swap your backends without rewriting detection logic, because your detection logic only relied on OpenTelemetry semantic convention fields. Now, you might be wondering, but yeah, if it's version and changes, then what happens if, I don't know, service A decides to upgrade and use the new conventions, but service B and C and every service else where in the cluster is on the old one, but I have to run service A on the newest version because of some vulnerability fixes? Good news is OpenTelemetry got you covered here too. The schema processor helps you use different versions of the semantic conventions. Basically allows you to downgrade that particular service's signals to the one you are currently using and buy you some time to write the migration logic you might require in the future. And like that, I conclude my talk, and I just want to give you a really nice thank you. And I listed some sources and some possible contact information for me. And I would say, rage bait question is the burning question. Should I rewrite all my apps to emit OTLP natively? And the short answer is, of course, no. You have to leverage the OTel bridge API and existing collectors, bridge them in the pipeline to achieve standardization without the massive refactoring tax. And for the last quote is the standardize smarter, not harder, bridge the gap iteratively. Thank you. Should I? Let's see.
Okay, so the talk back then was kind of quick, so we have like 15 minutes, so you can feel free to grab a coffee in the meantime. Okay, so we will continue with Bence from Axiflow, and he will tell us how to actually configure your OTel collector for the real production environment. So, stage is yours.
Yeah, that's correct. Hi, everyone. I'm so excited to be here once again in KCD Czech and Slovak. I'm going to talk about how you should treat your OpenTelemetry collectors based on my field experience with it working at Axiflow. So, a few things about me. I'm a software engineer at Axiflow. We are mostly working with observability and security-related tasks. I'm a professional collector breaker, and I'm also a maintainer of two CNCF sandbox projects, Banquets and the logging operator. If you haven't seen a collector before, it's a very cute being. It simply just receives some data, it performs some processes on it, essentially, and finally it exports it somewhere in your most favorite destination. And along the way, you can have connectors to route between your pipelines. You have distinct pipelines per signals, like logs, metrics, traces, baggages, and profiles, and so on. And you can have other extensions for storage and authentication. So that's the collector in short. And it's a beautiful process. Like OpenTelemetry is a great solution for observability nowadays, and everyone loves it. The configuration is so simple. You can read through it. It's so beautiful. But until it's just not. So last quarter, a customer came to us. They had a beautiful pipeline. Their tail sampling was working. Their processors were really beautifully configured, and their pipeline was just beautiful. And every 12 minutes, they got an OM kill, and we started investigating. A few things they did before: they added retries, they added persistent queues, it died with persistent queues, they doubled the memory, it died with double that much memory. And until we looked at the config more in depth, we came to a conclusion that it was not broken. They essentially made their collector broken. So this talk will be about a couple of battle-tested war stories that I've learned along the way, common mistakes that I've seen people make with their collectors, starting with situations where it got OM killed, situations on a restart or update, it was losing some data, and the burden of maintaining your OpenTelemetry collector configurations, which is essentially really hard, and it can get out of hands if you are managing a widespread cluster. So let's jump in. So first, when you get an OM kill, it's some infrastructure and DevOps folks treat it as a mystery, but it's actually not. In Kubernetes terms and in the world of Kubernetes, when using OpenTelemetry collectors, you probably set your memory limiter because it's like the first processor in every pipeline is the recommended one. But there is like a small nuance that you need to set the go-mem limit environment variable to 80% of your pods limit. A lot of folks miss that, and well, the kernel will just destroy the process. And obviously, you have your enrichment and other processors that essentially builds up a lot of cache along the way, like Kubernetes attributes, and also on tail sampling, when it needs to cache or buffer a lot of those traces before constructing the whole thing again, and sampling goes along the way. So first of all, how do you fix the memory limiter problem I was talking about? It's really simple. You just give it an environment variable, set it to 80% of your pods limit, and you're good to go. What do you win with it? Well, the memory limiter in itself is like really simple. It just basically periodically checks whether the memory usage of the collector, and if it's too high, it refuses data or forces a garbage collect to reduce the memory consumption, essentially. But in itself won't help you because Ghost garbage collectors defaults are not bound to the workload that is being handled by the collector. So you need to set that go-mem limit so the garbage collection will run at 80% of your pod limit rather than your kernel deciding. It's like a really simple fix. Jumping onto the words of traces. So if you haven't seen a trace, this is a trace. a bunch of spans across time, essentially. If you look at that waterfall diagram there, the root span is like a request made to the API /order post request. And the service did some authorization, it queried the database, it got some things out of the cache, and finally it published an event. So that simple it is. And along the way, it got some attributes, some other metadata information that will make it more simple to debug some issues within your code. But I like to think of spans as like an analogy of an onion, because the outer layer is like, it consists of layers, and the outer layer is like the resource that we enrich with Kubernetes attributes, for example, that I was talking about. Like the service name, the pod name, and the namespace name. You have scope in the middle, which consists of the instrumentation library used, some specific version, and other metadata. And in the lowest layer, you have the span itself, which consists of name, the duration, status, and other attributes that you placed on it. If we are talking about tail sampling, the policy name that triggered during the tail sampling will also be placed on the span itself. So, and since Kubernetes attributes enriches the outer layer itself, and if that cache can blow up, eventually it will be bad for your traces and bad for your tail sampling. So that's why we care about it. So now we understand the trace. Why do we care about that, and how it connects to memory consumption? So the problem that I was starting off with was coming from a tail sampling problem, and with the GoMem limit, but that was another thing, and it's connected. So what happens with tail sampling is tail sampling will hold your traces in memory until your decision wait time, and once that is hit, then it will just fill out the buffer. But eventually, if you have a constant load of traces coming in, that buffer size will be a constant memory limit that you are constantly will be hitting. So in my silly example, if you have 1,000 traces per second and you have 60 seconds of decision wait time, and you have a heuristic that you can calculate based on that blog that I encourage you to read, in my example, that's 20 kilobytes. If you count that, that's 1.2 gigabytes constantly in your buffer alone. And that's that basically the whole formula is not going to save you. What will save you is if you configure your GoMem limit and your memory limiter based on this calculation. And the formula will just tell you what kind of seat belt do you need. And so it won't trip every 5 minutes or so. So if you didn't do this math, you just basically didn't enable tail sampling. You just scheduled an OM kill, and your tracing will be so sad. So I found this is like a really simple tail sampling example. The tail samplings that I've seen on our customer side were more robust and a lot more interesting. But in simple terms, this is what you should start off with. So what do you care about within your trace? So the first thing you care about is essentially your errors, obviously, the slow calls what's happening to your system, and obviously to have some information about how healthy the system is in itself and how well is your tail sampling itself working. You should sample the rest of those. So this is what you can see here. And with settings like this, you can save around 60 to 95% of cost, depending on your error rate and while keeping all the critical traces. One addition that I would like to make here is that I have seen many tail samplings where people only use the probabilistic type of tail sampling. It's an interesting one because probabilistic is one of the most useful policy types on its own. But if you're only using that type, you should stick with the probabilistic sampler processor because it's a lot better. It doesn't buffer. It's much cheaper. So essentially, tail sampling worth it if you are using other types of policies as well. And let's connect everything together with putting in the missing puzzle piece with Kubernetes attributes. So Kubernetes attributes is what will enrich our outer layer, the resource layer, with some metadata that it got from the API server bound to that service account that we use for authentication, because that is connected to a cluster role, and whatever that cluster role has permission to scrape, that's what we are going to use for enriching our data. So for example, if that cluster role does not have a permission to read deployments, then that will be missed out. So, but that is an interesting topic because you can have the least amount of privileges within that service account bound in that cluster role bound to that service account for resources sake. But another interesting topic on that front is that if you are in a cluster where you have around 200 nodes, so if you are deploying the collector as a daemon set, you have 200 collectors running simultaneously and pulling 200 informers along the way. So but you obviously don't want that. You want to limit the nodes or the collector's work to the node which is it working on. And you can do that with the missing piece, the node from mvar, which comes from the downward API. It's on the pod spec. You should definitely set that one. And in that way, your collector will only query from its own node and not everyone's else. So your Kubernetes attributes cache will not blow up. Three things that I've added at the bottom is that the cluster rollback that I was talking about. So limit your permissions. Wait for metadata is an interesting one. It's biased a bit because it adds latency, but it's useful. What it does is that it blocks the collector startup until the Kubernetes API sync finishes, but it can be useful, but obviously it adds latency, and pass-through is a special one that you should consider when you're using gateway agents along the way. And if you connect all of this, and hopefully nothing will blow up because your memory limiter and your environment variables are correct, that's what you get out of this. Instead of having a request that essentially says you nothing about where the problem is, you have something that tells you which pod on which node, which cluster, which deployment is going wrong or having sort of problems. So yeah, that's it for the first package. Essentially, tracing is your friend if set up correctly, but as you have seen, there are like a lot of moving parts around a simple problem within OpenTelemetry itself, in the collector itself. The next problem was an interesting one, and you can lose records in many ways, but the most common way you lose your records is by misconfiguring your batching and your sending queues. So taking into example, like if you have some receivers accepting some data and it essentially sent out less than what was received, if a stick term was happening on the fly, well, the problem is that the batch shutdown did not handle stick term historically good. Because the problem with that was that when the receiver got a message, it acknowledges that, and the batch processor holds the records in memory until the batch limit size has been hit. And in the meantime, if it got a stick term, then it didn't drain that buffer. It didn't do anything with it because it was not in sync with the shutdown. So you essentially, all of that records that was in memory are lost. And there was thankfully, there are two ways out of this, one better and one is like a mediocre one. So as I said, it was not synchronous with the shutdown itself. So in version 1.51, they made it synchronous with the shutdown, the batch shutdown, so with the cleanup. So if you must stay on the batch processor, which is right now not the limited recommended one, because it was moved from the processor side into output batching. So if you must stay, for whatever reason, on the middle upstream processor-based batching, you should definitely be above version 151. But the real solution is a twofold. So as I mentioned, batch processing has been moved to the output side into the sending queue session. There are a lot of benefits to it that I will cover on the next slide. But for this one, as now we have per output batching, essentially, if you pair that with a file storage extension of some sort, if the queue and everything else will be on disk and not in memory. So if a seek term arrives, the disk queue will be drained to the disk and before the processor finishes, and the next run or after you finish your upgrade or restart or something like that, the collector will essentially just pick up where it left off. And simple as that. So it will survive your rolling restarts, your auto scales, and your node drain, and so on. So it's, if you can just move from the processor batching to the output batching, and so on, it will be better for you. And just to see some a simple example of what that would look like. So we have a faster output and a slower output in our example, Loki, and let's say an S3-based something output or cold storage one. So what we win out of this output batching is that each of those exporters gets its own output and own batch config, own retry policy, and so on. So every one of those goodies will be applied to each of those exporters. So why is it good for us? The first place is that in our example, Loki needs fast batches, logs visible in seconds on the dashboard, and so on. Whereas on the cold storage side, on S3, S3 charges you per request, so you want to wait for that big size of a batch to send in. So when Loki essentially bursts or something bad happens to Loki, if we were to use the upstream batching, it would stall the code archive for ourselves too. But since we are having distinct batches or sending queues happening on each of our exporters, independent rack pressure kicks in. So what happens is that each of those exporters will not stall one another. Whereas with the middle output or batch processor in the middle would be the problem is that if Loki would burst, then the other cold storage endpoint would have some bad news for that too. A small caveat on that side is that still the persistent queue writes on dispatch and not on ingest. A small thing you can fiddle with on that front is that some receivers also have persistent storages that you can leverage, and you should definitely do. So make sure you check that one out for if your receivers are supporting any type of storage solution. Now that we made sure that our pipeline is essentially somewhat healthy, we should might as well talk about what are the common ways that you are deploying your collectors, and how do you know whether it is alive and kicking. So first and most probably the most frequent deploy approach is the daemon set or the agent version, which is essentially your application is directly talking to your collector. Enrichment happens on the collector itself with Kubernetes attributes or any other enrichment processor of type. And the latency between your applications and the collector can be measured in like microseconds. So it's really great. And if you enabled the Kubernetes attributes environment variable that I was talking about, each collector will only see its own node traffic. So definitely do that. On the gateway side, gateway is like, it wins on scenarios where you need a central policy with tail sampling at scale and other responsibilities for example, multi-tenant routing and so on the gateway level itself. So, for example, if you're using tail sampling along the way, all spans of a trace needs to connect at one point, and that should gateway be a good answer for. And how do you know it's alive? Well, I might as well think that next to the memory limiter processor, the health check extension is a no-brainer to put in your config along the way. It's basically it will create an endpoint that your readiness and liveness probes will hit if you are using the OpenTelemetry operator, which you definitely should, because it knows best how to handle your collectors in a Kubernetes environment. If you can allow that and you're not on premises or VM or any other scenarios, you should definitely use the operator. And also for logs and metrics, use info. If the volume hurts, you should turn that down to warn, debug while investigating. And metrics should be on detailed, and you should scrape those. I must say, I have seen metrics endpoint turned on many occasions, and they were not even scraped. So that's a funny one. And now into the real problem. So if you have an OpenTelemetry collector and it's not just a baby config, but it's like a production config itself, it will be big. And my infrastructure folks knows best that you have to maintain that configuration on itself. So let's say you have a bug in that you upgrade it to another version, they made a breaking change, you need to find that. Well, sometimes the logs help you, sometimes don't. Sometimes you have to dwell into the docs, sometimes you just figure it out. But nonetheless, if logs don't help you and the docs don't help you, you are left with your eyes beating on that 360 lines of YAML, or your AI pal helping you out for a small cut. But that's essentially it. But I have some sort of a better idea that I would like to show you. As I said, the OpenTelemetry operator is like a half a success in a Kubernetes environment because it knows best how to handle collectors in Kubernetes. So you're halfway there. But what if you could have a well thought out config based on your Kubernetes knowledge from just like a couple of lines of intent? And that is what I'm going to show you in the upcoming demo that I've prepared for you. So this is the cluster that I'm rocking. It's currently sending into Elastic. I might as well just go through the manifest that we are using. So a few words about the telemetry controller. So the telemetry controller is a Kubernetes operator that essentially configures OpenTelemetry collector custom resources passed to the OpenTelemetry operator itself, and the heavy load of the work after the config generation and the collector itself will be handed to the telemetry controller, and everything else will be passed on to the operator. So the first resource of the telemetry controller is the collector resource itself, where it will be placed and which tenants it watch for. In telemetry controller's words, the tenant itself is like a being that conducts of many namespaces. You can match on those namespaces based on the labels based on those namespaces, and those are your log sources. So every resource that within your namespace, you are going to essentially cover that with a tenant, and you're going to collect logs from that. And you also have your subscriptions, which is the resource that you give to your customers or your users that can subscribe to a small batch of that tenant's own logs. Subscriptions are really simple. They have an OTel condition and an output that you define somewhere else, which name and in which namespace. In our case, we have 2 tenants, 2 subscriptions, and 4 outputs, 2 outputs per tenant. We have an Elastic one, and we have a shared file archive that is pointed to the same location. And what we have here is that, first of all, I would like to show you the configuration itself after you deployed the telemetry controller itself and apply those custom resources. This is essentially the config you are going to end up with, but I'm not going to kill you with this config. I'm just going to paste it into OTel bin because it's a great visualization tool, and this is what you will end up with the telemetry controller. So a few best practices that I have been talking about. We are having the memory limiter as the first processor in every single one of our pipelines. We have essentially that 3 layers of abstraction going on, so the tenants, the subscriptions, and the outputs themselves. In the middle, you can see that we are taking sample metrics on the tenant and on the subscription, and a small batch on the output level as well. We are enriching with Kubernetes attributes. We have a very sophisticated config on it, and also the kube node name, the environment variable magic that I shown you is also there. And we are having file log receivers that, because in Kubernetes words, you know that log management is a non-existent thing by design, essentially, because every single one of your workload logs are getting persistent into war, log, pods, pod UUID, pod namespace, and so on. And you just need to mount that to your collector, and you are going to essentially work with that one. So it's really simple to collect logs in Kubernetes, in my eyes. Enriching them and working with them is another topic. And on the flip side, on the output end, we can see that we have our exporters and so on. One thing I would like to point out is that we are taking like redaction really responsibly, so we are not leaking any secrets within our OpenTelemetry configuration that we are saving as config map into the cluster. We also have the health check endpoint, and if I can show you the OpenTelemetry collector resource itself, I promise it won't be long. We have the liveness probes, the readiness probe, and so on, and the startup probe that I was mentioning that the OpenTelemetry operator injects to the custom resource if you have that health check extension. So the operator knows best how to work with collectors in Kubernetes. And I really wanted to show you a disaster scenario when Elasticsearch goes down, but I found out that they support storage in the interface level, so it's not connected in. So I chose a bad exporter, so I will show that the next time. So as you've seen that config, I didn't write any of that. So the memory limiter was the first processor in every pipeline. The go-mem limit was set and to 80% of the pod limit that's calculated every time that you basically change your configuration. The file storage extension was part on the receiver side and also on the exporter side as well. You had sending queues filled up for all the exporters, Kubernetes attributes fully configured, and you write only 50 lines of YAML. So life is great with the telemetry controller. So a couple of take-homes for you. Tail sampling is a really pesky one, and it's really easy to get that wrong. So be cautious with that. Keep the best practices. Keep errors. Keep slow. Sample the rest, and build from there. Everyone will become better at tail sampling once they start using it and seeing it in action. Plus, the memory limiter is really important, and the go-mem limit part is also. So keep an eye on that. Kubernetes attributes, if you are in the Kubernetes settings, enrich for good, filter node local for your costs and your own sanity, and per output batching, move to it if you haven't already, because the processor-based batching has been deprecated. So make sure to do that, and enable file storage on the exporter and also on the receiver side if you can. There was like a really few things that we didn't cover in this one. Airbag for Kubernetes, we barely touched on that. Multi-cluster gateways is a hot topic that I'm working on nowadays, and also back pressure and retries. I have a blog on that on the Axoflow blog, so check that out if you are interested. And if you want to talk about any of those, please catch me in the hallway and let's talk about that. So thanks everyone for listening to me. You can find my socials over here. If you're interested in the telemetry controller and the demo that I've shown you, you can find it over here. It's completely open source. It's part of kublogging and the CNCF, per to say. I don't know if everyone got it. Thanks. And also, thanks or congratulations to the OpenTelemetry team for the graduation. Yeah, I know it just recently happened, so I just wanted to shout out. And one last thing, if you could just rate my talk in here. It's a simple application that lets you rate my talk, so I would be glad to get your feedbacks on this. So yeah, thanks guys. Awesome. Thanks.
Okie dokie. I see a room full of people, so, invite everyone, because that's the highlight of the day, besides tomorrow's raffle. So, shall we start the most interesting part of today? We prepared a panel discussion with so many great speakers up here, most of them CNCF ambassadors or KCD organizers or contributors, anyone, the top people we have around, or the top. So it will be like pretty interesting discussion, I think. What we are gonna talk about. First of all, I'll let some time to introduce each and every one of you, and then to just frame a discussion a bit. Imagine it's like the 2 a.m. in the morning. You have your freaking AI agent running inside your Kubernetes cluster. It runs some random kubectl command like nobody has ever approved or seen. Your on-call is sleeping. And by morning, your production is half healed, half broken, and your CSO wants to know what have been done, who did what, and most importantly, who approved that. As you can imagine, your audit log says nothing, system, something similar, and this isn't theory. This isn't like hypothetical situation. It's already happening. AI agents are running at production, touching your deployments, closing tickets, mutating infra, shipping codes without any reviews whatsoever. And yeah, it's kind of interesting time happening. The human part approving anything is basically a fiction right now, to cut it short. And the last thing we have holding the line is our observability. So the telemetry is the only thing that can really tell what the agent did and whether you should be worried or not, as I can see it. So the question which stands out, and that's the pinpoint of the discussion, is your observability stack actually up to the job, or have we been like quietly downgrading your audit to debug for the past decade? So that's the thing we will speak about, and we have a vendor which is like watching the field closely from dash zero. We have a SIG maintainer which kind of hears the user complaints maybe from the end side. We have an engineer that digs right into the kernel with eBPF, and we have a builder that actually shipped something with AI within a regulated environment. So I think you will disagree on some stuff. To keep it spicy. Okay, so I'll let you introduce yourself.
All right, so I'm Yuri, I'm Principal Solutions Architect in Abound, and Abound, we are creators of Crossplane project. So I'm in customer-facing team of Solutions Architects, so we are helping organization like Fortune 150 to adopt Crossplane at large scale. And yeah, tomorrow we will have a talk exactly about running AI-enabled operations in a regulated bank. So excited to be here, thank you.
Hi, my name is Adriana Vilela. I'm originally from Rio de Janeiro, Brazil, but I currently live in Toronto, Canada. I am one of the OTel community managers, also a maintainer of the OTel and user SIG, CNCF ambassador, serial blogger, and I have a podcast. My day job is a principal developer advocate at Dynatrace, and tomorrow I've got to talk about what happens past the initial adoption of OpenTelemetry. I also love bouldering. I checked out a bouldering gym here yesterday, and I love capybaras because they're so cute and they make me happy.
Hey everyone, I'm Donia Chaiehloudj. I'm a software engineer working at Isovalent at Cisco. And I've been working on Cilium, which is the main open source product. It's a networking Kubernetes agent. And I also dive into eBPF because I think it's fun to understand what's under the hood. Otherwise, I like bouldering too, and I love swing dancing. I don't know if you have a big community here, but I would love to dance tonight.
All right, I'm Kasper. I already introduced myself this morning, but I can do it again. I am Director of Product Marketing and Developer Relations at Dasero. So I spend a lot of time in the community around OpenTelemetry, around Perseus, for dashboarding. And yeah, I just love being part of these communities. So I'm also an organizer of an event myself in Denmark, also for meetups, etc. So yeah, if you're in Denmark in November, stop by. There's going to be a cool conference there as well. We have CFPs open. But yeah, so I think that would be my introduction.
Cool. We'd love to come. Sure. Okay, so to start fresh, as you holding the mic, Kasper, you have watched like platform teams ship observability for quite some time, I think. And what is the one mistake you see them repeating all over again?
So yeah, I've been in this observability space for actually only a year and I don't know, 3 or 4 months now. But I come from a background of being an SRE, a staff platform engineer at a company in Denmark, a bank. And I can say one of the things that we struggled a lot with back then was basically we treated our sort of observability stack as a tool. We just took some tools from the ecosystem, put it out and say, hey, developer, go figure it out. And I think that was also the message that I was trying to convey this morning, that is probably not the way you should be doing it. Start treating observability as a product and create that foundation around maybe using OpenTelemetry as that foundation to make it easy for your developers to just get their applications into the cluster and start getting instrumentation and telemetry flowing so that you have a good baseline. You don't want to force your developers to configure everything in code and set all of that up. I think you can come quite a long way just using some of the tools out there, the operator to basically do the instrumentation for you. So I would say stop treating basically observability as this tool and start treating it more as a product.
Is there any specific feature you see being shipped but never ever used?
Yeah, I think also just remembering back to my time at Lunar, and I think we created a lot of custom dashboards in the platform, but I don't think anyone was actually using them. They were basically just going into the tools, trying out, because the situation always, so an incident is not always the same, right? It's always a different thing. So building a dashboard for a specific purpose is probably not what you are looking for when you want to investigate something going wrong in the middle of the night. You probably want a system that allows you to query things across all of the different telemetry you have. Maybe even nowadays with all the AI that you just mentioned before in natural language. I think that is where we are heading towards nowadays, is that we are coming to a point where we can just ask questions about our systems, and our systems will just give us answers back, which is really awesome, and it makes it so much easier when you are being woken up by a page at 3 a.m. that you could just ask the question of what is actually going on, and then it comes back with the answer. But I think the next step is also what I mentioned this morning, is really about this is going to be more proactive as we move further along, because I think right now many of the tools out there in this ecosystem and also in the different vendors is that it's very much a chatbot kind of interface still, that you ask questions and then you get an answer. But I definitely see this is moving more into a proactive state where the systems will, automatically all the time figure out what is going on. And when the pager then maybe, fires, maybe it's just a PR that needs to be approved or something else. I would probably not recommend putting things into the cluster itself and have it do all of those. I would probably build it around in the SDLC space instead of putting things directly in the cluster, so that you have an agent that maybe creates a PR. You already have GitOps in many cases, right? So maybe tap into that workflow instead of tapping into Kubernetes directly, because that could have some interesting consequences, I can imagine.
That's for sure. Thank you. Okay, Donia, a question for you. Since you have covered just a few moments ago eBPF doing something with GPUs, really interesting stuff. At what what point like the eBPF stops being an answer for you? What's the thing that it cannot cover?
Yeah, I think that I covered actually how to get metrics from your CPU and GPU and what is the behavior. But again, you need a context. Like you need to understand, like when I refer to inference, eBPF is not going to give you an answer about about the behavior of something depending on what you ask. So it's going to give you exactly facts and numbers. That's a metric. Then you have to correlate all this information with more context about what was happening at the beginning of your prompt. So I think that eBPF will give you insight about what's happening under the hood, like really deep, like granular, I would say, functions. So you can spot what is lagging, where is the latency or spikes, whatever, but it won't give you this context. So you have to build tools around that. It's just a foundation and a tool to get all these metrics, and then you can do something with it.
Cool. Is there some specific part that even eBPF still gets wrong?
That's a good question. I don't know if eBPF will get you something wrong because, again, it's just facts. So I think that depends what is the code that you're writing, of course. But when you're going to have, so for the people, maybe you don't know what is eBPF if you're not at the talk, I'm sorry. But eBPF is just a way to run dynamically code into your kernel without modifying the kernel itself. So you can get metrics on what's happening on your Linux kernel. And GPU device too now. What was the question? I'm sorry.
I mean, to reframe the question a bit, imagine like your AI agent running inside your cluster, and whether with eBPF enabled, you can tell whether your agent lies to you somehow.
I think that, again, I don't think it's about lies.
Yeah, I think configure it to inference, to get the actual data from the kernel, and if on top of that agent can still derive the information by its own, and it's still irrelevant.
Yeah, but again, it depends on the way you're writing your code and where you're hooking. So if you want to have a full picture of what's happening, you need to hook to the proper hook points, which is another debate, and how to hook point and find the proper hook point to observe what you want to do.
Yeah, okay, thank you. Next one, Adriana. Question for you. Since you are inside the OTel end user SIG, kind of interesting place to be. What mistake do you see the users making all over again that bites them later in the wrong possible time?
I think sometimes it's underestimating how much work it is to implement OpenTelemetry. And by the way, OpenTelemetry graduated recently, which is very exciting news.
Yeah, it is.
OpenTelemetry has a lot of moving parts, and so it can be really overwhelming. And I think if you don't take the time to understand what those moving parts are and ask questions within the SIGs especially, and I really emphasize that because the folks who run the various SIGs are so good at answering questions. Every time I prep for a new talk, I always, and it involves SIG OpAmp or Weaver or Arrow, I'm always terrified of asking them questions, and I shouldn't be because they're super respondent when it comes to that. But I would say underestimating the amount of work that it takes. I think the other one is within organizations, some organizations still treat observability very much as monitoring. They think that the two are synonymous. And I think that can be very problematic because it's still a very old school way of thinking. And so tends to be more, focus on SRE, when observability really is all about involving everyone within the organization, and it starts with development. It's not just about getting metrics from your infrastructure. It's not just about getting logs from your infrastructure. It's also about getting the traces, logs, and metrics from your application and treating it as trace first so that you're able to tell that story, so that whether it's a human troubleshooting or an AI troubleshooting, you have those breadcrumbs that tell the story.
And in the event that like the company's budget goes off the rails regarding the OpenTelemetry and their like budget on it, what's the signal that they are most tempted to cut the first, that they should not?
They're probably tempted to cut, I would say, traces, which is the most important signal. And I think there's a very comfortable fallback on metrics or even logs, because that's what companies have been used to, right? And I think, going back to your original question, there's also this tendency of, through zero code instrumentation or auto instrumentation, where you don't have to touch your application code to instrument it. You can get a lot of telemetry, and just because you're getting a lot of telemetry doesn't mean that it's good telemetry. In fact, a lot of it is crap. And so to be able to identify that, I think a lot of organizations are really surprised when they turn that on and they're like, oh my God, I can't make sense of anything because now I'm having to do an archaeological dig, which is counter to what observability was meant to be. So keeping that in mind as well. It doesn't mean don't use it, just be very mindful of it.
That's very correct. Thank you for that. Okay, sure, go ahead.
It's an interesting question, because like you wouldn't ask like a pilot to put on a blindfold, right, and remove half of the actual instruments, because they are kind of needed in order to understand what is going on.
They can go by memory, you know.
Yeah. No, I just wanted to make that point that it's a little bit crazy. It's a crazy ask, right, to remove like partial views of your systems.
You end up partially blind, yeah. Cool. Yuri, kind of fast forward for tomorrow's presentation, but did you ever experience the self-healing caused by AI agent to do something you like really regretted?
That's a good question. So first thing first, like I'm not fond of the practice like put kube control on the AI agent stuff. Like I'm more deterministic guy, let's say. So how we
That's how it should be. Yeah.
Yeah. How we try to lay out it with crossplane. So we have a set of deterministic abstractions that are still predictable and human can understand how they work. And only then we inject, if you follow crossplane v2 story, we have a new concept of operations like that can abstract v2 operations. And that's where we put this small, just enough AI prompts that can actually interface with the deterministic abstractions, right? So the core, the most critical part is highly testable and reliable, and our v2 operation stuff is doing this probabilistic part, right? So on a regret part, we can, I had an example of a cost optimizer in the form of v2 operations, and when it optimized a lot, so it understood the task like too eagerly, let's say, so it downscale the associated database abstraction to minimal micro type, and that obviously made it the operation not performing very well. So that's probably the case. But
task done, it was cheaper.
Yeah. So that's the part where you need to test your prompt as well. Also test the probabilistic part next to your deterministic one.
Yeah, cool. Thank you for that. Okay, and now the spicy ones. The question that everyone will love. AI agent or junior SRE in your production cluster? Which one gets the right access first?
I will always give it to the human. My thought on it is it's a lot easier to, first of all, I don't want to live in a world where we abdicate full control of our systems to AI. I think that becomes very dangerous. If we put too much of our, if we basically outsource too much of our knowledge to AI, then you don't have a junior who will eventually become the senior to take on that role. So essentially, if there's an issue, I do want my junior there. I can sit there with my junior and help mentor them and help them through an issue. Whereas with AI, yeah, it's, you know, you definitely like still have that intervention part, but I feel like sometimes it works so fast, and sometimes it's so easy to like hit okay, you know, when the AI asks you like, oh, are you okay with this change? And you haven't had a chance to think, right? Because so often we're kind of on autopilot that I think it becomes really, really dangerous. So yeah, junior always.
I have the same hot take. But I would like to add something else about more political aspect, I would say, maybe. But we are driven by capitalism because we are working for companies and it's about money. So in the end, most of the people are going to take decisions regarding money and how we can be more productive. So of course, AI agent is going to do a bunch of things faster than a junior because the junior is a human learning stuff. So if you're taking decisions, if you're someone in this room, I feel like just think twice before asking a senior engineer to ask the AI agent to do it. Just put a chance like and a coin for a junior, because I don't know what they're gonna become, these juniors people. So yeah, that's my hot take about it.
Yeah, I'm completely agreeing with you two. I will also choose the human first, but I guess the human would also have access to Claude Code or something, right? So they could get some insights from that perspective. But I think also that, as you also said, I wouldn't put an agent in the cluster right now. I think what we will be seeing in the next months, probably because things are moving so fast, a month feels like a year these days, is that we will probably see some like evaluations, and at some point when some certain evaluation reached a threshold that I'm pretty sure that whatever the AI sort of reasoned itself into is with 99% the right thing to do, then for some areas of production environment, maybe that's fine, maybe that's good enough, and then we'll just let that slide through and have like, that will probably be a process that we see within the next months or years, that we are allowing the AI to do more and more, but still with some kind of guardrail in between that we can control and slide that back and forth as we see it.
Same question. Yeah, so from my perspective, you actually can put this just enough AI, as I described, but in a well-tested manner, right? So if you understand this prompt, how it will behave, so it's like will be in between of like totally probable design and something that you expect. So from my experience, like what we have in experiments, and they're available as reference platforms in our cross-plane catalogs, right? So like this kind of autoscaler that is looking on a various factor and evaluates and actually patches the database abstraction. That kind of makes sense. It's also something that you can implement in deterministic manner as well. So I see it's like on the border, like you can, as an SRE, a junior SRE as well, you can automate your own knowledge, quickly put into this V2 operation prompt, see how it behaves, and then productionize it. And you can decide either you leave it to AI to make it some probabilistic design, or you implement it in a well-established deterministic controller.
Cool. Okay. And one from experience. Each one of you runs, I think, some sort of polished observability stack at your company where you work. And as you all know, the observability stack can contain a lot of sensitive data. Imagine what will happen if some sort of evil people grant access to your data, and what's the first thing they will discover? Or the most sensitive one? What will you be ashamed of? Maybe if there's something like that.
I don't have any like specific
What's the thing
examples
they
right
like
now, but
shouldn't see? And they will.
no, I can share some experience from my past job at least, because I think probably most of you who has like running a platform of some kind that have a ton of developers like doing things. There's at some point a log line that just enters into a service that contains a little bit of, I don't know, a social security number or email or something that is not compliant, and it ends up in your observability stack. I've definitely seen that in my past job. Luckily for us, at least, it was super easy to just remove that data again. But that's definitely what I've seen. So, but you could start like building in things in, if you're running a project like OpenTelemetry, right? We have this concept of processes where you can define these processes to filter things that shouldn't be there, or redact social security numbers. Or if you see something that resembles an email, just redact that thing and keep that information, but it's redacted, so you cannot trace it back. So that would be sort of my answer to this. I've seen this happen, but there's also tools for you to run in your environments that can help you in this space.
I mean, seconded on making sure that you use the appropriate processor in the OTel collector to redact your data, because that is super important. From past experience as well, I worked at a bank for 11 years, and it's incredible how tight they are on security. I mean, I remember I worked on a team where we needed to troubleshoot production data, and we needed to like fill out so much paperwork just to be able to dump the production data into our development databases to be able to troubleshoot. And so that gives me a lot of hope that a lot of organizations are super strict on these things. But of course, I mean, hackers always find or try to find a way around it. I remember talking on my previous podcast on Call Me Maybe, we had someone who worked at in information security. And I remember that we tried asking him a bunch of questions about stuff, and he's like, I'm sorry, I'm not allowed to talk about that. And I think
NDA questions, yeah.
It's like almost like spy work, right? And I think, the InfoSec folks, they get a lot of crap when there's a data breach, but they are unsung heroes because the amount of like breaches that they prevent from happening is unreal, and they're not allowed to talk about it. They can't even like brag, hey, you have no idea, we just thwarted this breach. So I think it goes to show like there's so much stuff that's going on behind the scenes that they're not even, allowed to talk about, that we're not even aware of. I think our attack vectors get, I'd say, amplified now with AI, though, especially like, with MCP servers, for example, especially the ones where you're like running them locally and you're like, ooh, this looks like a cool MCP server. And then next thing you know, like there's some really unsavory stuff happening, and they've gotten access to your network. So I think companies are trying to figure out how to secure systems around that, especially. And also, I think there's just the overzealous AI agent where you're like, yeah, have at it, especially like when we do give a lot of autonomy to our AI agents. And I would say, I don't want to give the impression that I'm anti-AI. I'm not at all. I'm just saying, like, let's use AI wisely. And, I saw a post actually from Charity Majors on LinkedIn recently where she was making fun of the term human in the loop. And it was quite interesting because it shouldn't be human in the loop. It should really be human in control. At the end of the day, we are the ones who have the authority over our AI agents, and I think it gets really dangerous when you get into situations where you're just blindly giving like merge powers to your AI agents, and your AI agents are reviewing the pull requests, and I think that becomes extremely dangerous. So we just need to make sure that we mind our AI agents, and we are the humans in control to prevent security breaches.
Is the question still out? Yeah. So the original question was like what I would be ashamed of, right, to observe, to push into observe. Yeah.
Observe to find out.
Yeah. Yeah. So I'm a simple man and cross-plane builder, right? So anything that I'm ashamed of, I put behind the API line, so it's not visible. So That's an easy answer.
That's a great answer. Cool. And what is the next question? Okay, interesting one. Since we have already touched it a bit in some questions, but what is the industry trend that you see from your all backgrounds that like makes your eyes roll out and that you like most likely not see happening in the future, but you see like the trends go that way? What is the best thing in quotes you see for the future?
That's a hard question. I don't know if I have something specific. I would say that last KubeCon I was just seeing AI on every stand. Like every booth had AI that was not present like a few months before, you know? So I just feel like we should be cautious on what's put behind on any like product that is just saying we are doing AI, and if it's making sense, and also if you want to put your money in there. So yeah, I don't know if I don't want to bash also on any people, but yeah, I don't know.
I think from my perspective, I just talked to someone in the hallway track earlier around that our job as engineers today is sort of changing from writing code to now being just reviewers of pull requests, more or less, right? I think all of that context switching is something that is really, really tiring, and that I hope we can like find a good way to solve, because it's really tiring just reading PRs all day. Anyone like experiencing that as well in here? Yeah, I see a few hands, yes. And people are shaking their heads.
Yeah, just on that, I'm sorry if it was not the question, but there are a lot of discussions in open source about like how to manage like all the contributions made by open source contributor, but that are generated. And there is a lot of crap out there. People are not trying to understand the project, and they're just submitting things. And there is like currently a whole discussion between open source maintainers and governance around like how to make open source projects still viable in this generative AI. So I think that's touching what you were saying.
Yeah, I'm also creator and maintainer of another open source project called KGB, Kubernetes Global Balancer, that provides global resilience across multi-region Kubernetes clusters. So I start to receive these PRs that like very verbose, have a very verbose description, and I started to be allergic to that, right? So like if it's too verbose, then it's really, most probably it's not high quality, so that's kind of a bad sign. Yeah.
I wanted to add, I think, you know, whenever there's a new technology, we as a society just love to jump on everything. Like I was actually listening to a podcast today, which was talking about like, oh, when YouTube became a thing, all of a sudden every company out there had this need to put like YouTube videos embedded in their web pages. And do you remember when everyone and their brother and sister was like trying to incorporate blockchain into everything? And crypto was like kind of this like crypto this, crypto that, and then that kind of died. And I feel like we're gonna see a little bit of that with AI. I don't think fully, but we do have this, I think organizations have this like panic response to new technology because they don't want FOMO. So like when this AI stuff started to like really gain traction, everyone's like, oh my God, if I don't do that, my investors are going to get mad, and then what, right? And so I think a lot of companies are having like very knee-jerk reactions to this, but we are going to see, I think, eventually a stabilization as the sanity starts to return to organizations, and then they find like an actual good use and sort of it's almost like an equilibrium between AI and like finding a place for AI in their organizations. Like we're seeing, you know, a lot of these like tech layoffs that are results of AI, and everyone's like, oh, laying off like tons of workers. And then they're like, oh, this is actually like using AI as much as we're using it is actually costing us more money. So now it's like, there will probably be layoffs in tech related to AI, but maybe not in that same initial scale as companies kind of sober up and realize, oh, it's not exactly the way that we envisioned it initially.
And the last one from my side, for those of you with a bit of a SRE background, has any one of you had to like reconstruct some AI stuff that that your agent did in production, or are we like in the territory that thank God nobody asked us? I mean, yeah, something happened, and then auto heals with your AI agent, and you know.
So I'm fortunate enough to not run things in production anymore, which I'm really glad. So I don't have like a full answer to this. So, but again, I would just like encourage everyone to not put like AI directly in the cluster right now. Maybe just hold your horses on that and see where things are going.
Yeah, maybe I can answer this one. So I had like two versions of it, right? So some like kind of agent can create some incident for customers, and we had to debug, right? And in our infra as well. But the most painful thing is actually to debug some AI-generated code, right? Especially like some cross-plane-based composition generated with Go templating. So people tend to like, sometimes go easy way and just generate like stuff that looks verbose, right? It kind of works. It even can do the stuff, but it's totally unmaintainable. So that's something I have to fix.
Yeah, I feel your pain. Cool. Let's take questions from the audience. We have a bit of time left. Okay, so first one. What looks more dangerous, junior AI agent, junior with AI agent, or someone who thinks is not junior anymore and uses agent? Bit complicated, you can read it. Thanks for the question.
I think the last one, someone who thinks they're not junior anymore and uses the agent, because I think AI gives you a very false sense of confidence, and I think that false sense of confidence ends up being dangerously infectious.
Yeah, I don't know, maybe not a junior, yeah, who thinks he's not junior anymore. Maybe he's senior enough in a sense, but yeah, we don't know. That's a good question. I feel like all of them. Expansion. Yeah, I feel all of them are kind of dangerous, but you have power to just balance it or to control it. Like a junior, you're gonna review the code. AI agent, hopefully you're gonna review and say yes or not. And junior with agent, I feel like that's today what's happening. I mean, everyone, we are using agent, so that makes sense. I was talking earlier, one of my friends, she's a CTO in a startup, and she recruited junior, and she told me, like, he's shipping features so fast, I don't have the time to understand, like, the topic that he already shipped everything. And I'm just like, I feel overwhelmed by AI and the Gen Z coming into the world of, like, engineering. So that's very interesting.
Yeah, I would just say you probably have like a proper process in place, right? So whoever of these options there should probably be catched in some kind of PR review or something, right? Even though I know people were like really shaking their heads before, but hopefully there is a process in place that will catch these things before it actually breaks production.
Yeah, I think on this topic is just very important for a human in the loop to understand how good and bad looks like from a code and operation perspective. So it doesn't matter if junior, he or she is junior or not, but if there is a good sense of quality, so I can trust this person. If the person is totally lost on the topic, so this AI-generated slope can leak to production.
Okay, the next question I think we have already covered. So I'll switch to the last one. So opinion regarding ownership in the later stages of AI integration, where AI creates changes, AI reviews them, AI deploys them. Should teams still be the owner?
I need to observe it.
I think the team still needs to be the owner. I think we need accountability. We can't. Otherwise, Skynet's coming for us.
Yeah, it doesn't really make sense to put like an AI agent's name on it and then, hey, you own it. That needs to be someone that is responsible for this thing, right?
Yeah, I think it goes with the new like commit standards that are emerging in the cloud native space. Like now you have to put, especially like on like Linux, now you have to put like the model, the LLM that you're using, and the model assisted by. And I just feel like you're the owner, and you've been doing that with that tool. And I think it just like fits like all the changes or review and everything. Like you're doing it, but there is AI tool assisting you.
Yeah, so like for the ownership, I think like if a person engineer is more like on the loop of the development, right? So we are more steering the design and overall high-level patterns and practices, right? So it's also one of the things that I see changing even in my own workflow. So in some places, I already do not care about the code quality, like we are working with Tobias on some project, right? And we are really writing the loop and writing the wave, but we are steering the core patterns and we are like practicing TDD and all that stuff, but we are already not understanding each function of the code anymore, right? And that's the ownership, right? But it's already, we transferred this in this specific project responsibility to AI for some core part of implementation. So we're riding the wave, steering the design.
Okay, and with that, I will close our panel discussion. Thanks once again, Kasper, Donia, Adriana, Yuri, and thanks the audience. 2, 1, 2. Yeah. Are we live? Raz, dva, tři. Raz, dva, tři. Oh, okay, cool. Thank you. Okay, sorry for a bit of a delay. Next talk will be by Mohamed from SUSE, and he will talk. Sorry. Okay. I haven't said anything. And he will speak about cost-effective AI inference. So the stage is yours.
Thank you. Yeah, so thank you for being here today. We will discuss how we can do cost-effective AI inference, outside of that frontier AI lab world and hyperscalers. So a little bit about me. My name is Mohamed Belgaied Hassin. I'm at Mirantis, and for somehow the logo here is not showing correctly, but you will excuse me for that. I'm the original creator of 3 cluster API providers. Some of them now have been taken over by other teams, but yeah, so these are CAP RKE2, CAP HV, which is for Harvester, and CAPOX, which is for an infrastructure provider for Oxide. At my company, I help customers implement cloud-native solutions, and my focus with them is around, infrastructure abstraction. Good. So today, I will give you first a role of a chief data officer at a hospital, okay? And we'll see what kind of problems you might have. So your boss comes to you and tells you, I need an AI strategy. His motivation is that his hospital is understaffed, and the doctors and medical staff are overwhelmed by administrative tasks and a lot of things to do, and there are a lot of patients, etc. And he thinks that he's hearing AI here, AI there, and he says this thing should at least help me lift up a little bit of the burden of my doctor's shoulders. So and when you hear him, you actually agree a little bit, because you heard about different healthcare use cases for AI inference. Such as structuring messy medical notes, or anonymizing data for usage for research, for example, or assistance with diagnosis. However, the data that you have in hand is not easy to handle. It's really sensitive. It's not only personal data, but it's health data. So you have to have compliance with things like GDPR and HIPAA, and etc. So because of that, the public cloud or public AI inference endpoints become really a no-go. You cannot just trust, public services. You need to have something that is on-premise. So you go and look for on-premise solutions, okay? The problem is you find 2 extremes, at least if you just follow, what you hear, what you see, like these headlines and stuff, whatever you can see in the, for example, on KubeCon main stage or something. So first of all, you will see production-grade AI deployments, and frameworks, but these are mostly built for data center scale infrastructure. So I'm thinking about GB300 clusters, huge machines that, or huge racks that would cost millions at a time. And this is what basically makes the headlines these days. And on the other hand, you see hobbyists that are making really wonders with consumer GPUs, sometimes single GPUs, or in this particular case, maybe a couple of them, but they are doing things that are interesting. The only problem is that it's not resilient, it's not observable, and it cannot be used in production. And I do think that most of enterprises will live in the middle, between these 2 worlds. That means that at the same time, they cannot afford the huge GB300 clusters. And on the other hand, they need the same approach for production-ready deployments that will make, make them able to operate securely this infrastructure or these services. So the rest is actually, these people is the rest of us, okay? Maybe not all of us need this or have very strict requirements about having data on-premise, but we have also that idea of maybe being more independent from cloud providers or AI frontier labs. Anyway, if you focus again on that chief data officer of the hospital, it's just an example, because outside of that, there are a lot of enterprises that have exactly the same kind of profile in terms of requirements. We have government agencies, we have financial institutions, we have legal firms, we have manufacturing companies that want to preserve their intellectual property, and many more, insurance, energy, telecom, whatever. So the pattern is always the same. All these enterprises have AI use cases that they want to deploy. However, they all have a reason to not let their data go away, go to the public cloud, go to AI inference provided by online endpoints. Okay, so here the photos are. So the rest of us, what do we all have in common? First of all, budget. We cannot buy the GPU farms that I mentioned before. These cost really millions. And the AI budget for most of enterprises is just a corner in the IT budget overall. It's not something that you can put a lot of money into. If you look at the team sizes, these are usually also pretty small, at least in comparison. You might have maybe 2 people, maybe up to 5, managing a Kubernetes platform, maybe a platform team. But you do not have this extensive machine learning teams creating new models and fine-tuning existing models, et cetera, et cetera. And this is backed by recent research. For example, in a 2026 research from DigitalOcean, their results show that 44% of enterprises that put money into AI, they put 75% to 100% of the budget into AI inference only. So basically, they just handle inference as another workload in an existing environment, okay? And this existing environment is mostly Kubernetes, or at least in this room here, you probably use Kubernetes for deploying various types of workloads. And you're wondering, can I do the same thing with AI if AI needs this huge compute requirement to achieve simple use cases? Well, let's take a step back and continue our research into how can we answer this challenge. And now we remember our hobbyist. We said that on one extreme end, there is this hobbyist who is tinkering with his GPU rig, and he's doing wonders. So the question is why? Why is he able to do wonders? And the answer is open weight models. If you take a look at, I don't know if everybody here is comfortable with AI jargon such as open weight models. So open weight is the equivalent of open source, very vaguely, in terms of AI models. These are models that are available to download, to use, and to modify on specific platforms. And they have gained a lot in intelligence and capability in the last year or so. For example, a model that can run on a very simple consumer-grade GPU, such as an RTX 4090 with 24 gigabits of RAM, today handily beats a frontier model from around 1.5 years ago in many metrics. So open weight models have become really, really capable. And they come in different sizes and need different levels of infrastructure. But many of those that you can deploy on simple consumer hardware are already capable of answering a lot of use cases. These use cases can be RAG and internal document and knowledge base analysis. It could be structured data extraction from messy text and notes and whatever. It could be document summarization and profound analysis, or OCR, for example. A very simple use case for AI today can be just taking huge amounts of written notes and paper documents and digitize all of that, put it into databases and make it more structured and more useful. And also, and probably all of you know about this today here, things like code assistance or agentic AI. All of these use cases are today possible with on-premise, self-hosted, open-weight models that run on very commodity hardware. Okay, so let's summarize our situation. We know that the demand for AI is real. There are useful use cases that many enterprises want to at least test and implement. The use cases that they see should provide value. There are capable models that exist out there, and these are, there is also cost-effective and good enough compute to make this work. So what's missing? We talked about that hobbyist. So what's missing? What's missing is a production-grade tooling to run inference in production on modest and also heterogeneous hardware, because you might have GPUs of different types and stuff. Or is it actually? So we mentioned that the rest of us, this middle ground, already probably has teams that know about Kubernetes and deploying workloads in production and stuff like that. What if we use most of these, but maybe with a small twist? Let us give it specifically AI inference superpowers. So this cheeky sentence, you might already think about, an agent that goes into Kubernetes and does stuff. No, actually, that's not what I'm thinking about. I'm thinking about here a number of projects, CNCF projects that exist already that answer these challenges for you. The first of them is at the infrastructure level. You will probably not be driving a small rig with 3 or 4 GPUs, right? You will have way more users than this hobbyist who probably has 1 user. You need something to scale, and you need a lot to monitor, to control. You need this resilience that in Kubernetes, et cetera, et cetera. And at the infrastructure level, the scalability thing can be given by Cluster API. But today I'd like to show you 3 additional CNCF sandbox projects that can help you continue being more efficient, specifically cost efficient with Kubernetes and GPUs. One of them is Hami. I don't know if how many of you know about Project Hami? Yeah, a couple of already. So for all the rest, I hope I can give you some new information today. So Hami is about GPU sharing and abstraction. Okay, and I will talk a little bit more about it in a second. Then the second project is Kaito. Kaito is a project that handles language model lifecycle as a CRD. So it simplifies deploying large language models in your infrastructure. And llm-d is for advanced LLM routing for traffic. You probably know about Cluster API already, so I will not spend too much time on this slide. But the idea is that it can provision infrastructure for you, any type of infrastructure. It could be, in this case, for on-premise, it would be hypervisors such as VMware, Nutanix, bare metal, you name it. And it will manage the cluster lifecycles. That means that if you lose a node for some reason, it will respin a node to replace it. It is a sort of pluggable auto-scaling mechanism that you can use Cluster API to handle the infrastructure that is requested by an autoscaler. And that way you achieve something quite similar to what public clouds can achieve. So and at the same time, it is useful both on-premise and in the cloud if you do have that use case. If we talk a little bit more about Hami now. So Hami's idea is that we should avoid having a vendor such as NVIDIA completely control the GPU AI inference space. We should be able to work with any type of accelerator, and in this case, we're not only talking about GPUs, any accelerator for AI inference. So it abstracts the way that deployments on Kubernetes will call out the accelerators so that you don't specifically depend on NVIDIA, you don't specifically need data center grade GPUs of NVIDIA, you can use consumer ones if you want to. And also you can share these GPUs, you can slice them and use them accordingly. So that's the most important features of Hami. That way, you can maximize utilization of your GPUs, especially if you use small models compared to the capability of your GPUs. If you have GPUs that have a lot of RAM, for example, and a lot of compute, then smaller models might not use up all the capabilities or capacities of these GPUs. So you need to do GPU sharing, like running on one GPU, multiple models or something like that. Now, Kaito. Kaito is, like the problem that you have today is that, or that you had before Kaito, was that deploying a model on Kubernetes, meaning that you need to put together multiple things that need to interact correctly, like a VLLM to do the actual inference, choose the right version of VLLM for the right GPU, and which CUDA version, and figure out how you run this VLLM correctly, and how do you configure the rest of the components such as config maps and services and secrets and stuff like that. So it abstracts all of that for you. In Kaito, you deploy one CRD called Workspace that will handle for you the deployment of the inferencing pod, downloading of the right model, as well as continue to handle like service endpoints, etc., for your pod. So it simplifies specific AI inferencing workloads on Kubernetes. You can see it as the deployment for AI inference. And finally, llm-d, which is routing that understands LLMs. So in this case, LLMs have very specific needs. For example, for latency, you need to send, in a chat history, for example, you need to send the subsequent chats to the right instance because there is something called the KV cache, which maintains the chat context. And if the KV cache is not on the right instance, it takes time to just get it over from some other place, and that's not very useful. If you want low latency, you need to route to the right pod that has the right context in the VRAM. Anyway, so this is just, llm-d has a lot of features, but this is the most interesting feature, I think, which is intelligent load balancing, KV cache management and handling, and latency-based routing. Now, the 4 projects I mentioned actually work better together if you look at them as a whole. So you have Cluster API that enforces just-in-time infrastructure and elasticity. You have HAMI that maximizes efficiency and utilization of your GPUs. You have Kaito that simplifies deployment of models. And you have llm-d that handles the right routing. I need to go a little bit faster. However, we need to also not forget that we have people that know about Kubernetes and they want to see the same thing, and we need to reuse this knowledge. And that's also the case in Kubernetes because we have the rest of production readiness with Kubernetes that is with the resilience, observability, governance, and security of Kubernetes, business as usual in Kubernetes. Let me go through these slides relatively fast. Resilience can be handled by Kubernetes itself as an orchestration platform, but also by Cluster API at the infrastructure level, Kaito and llm-d for the higher levels, like Kaito for the model management and llm-d for the routing. Then observability. Alerting and monitoring dashboards, solutions like Prometheus and Grafana are also useful with AI inference. There are GPU metric exporters that exist for nearly all of the GPU vendors. NVIDIA has their own, AMD has an equivalent, and Intel has also an equivalent. So these can be plugged into the existing monitoring solutions to expose the GPU metrics. And then you have distributed tracing to analyze each individual request. Which path did it take in your infrastructure and how, and maybe do some troubleshooting on top of it. What is already the case for web services and stuff. And naturally, you have centralized logs and audit. Then you have governance through admission control. This is also relevant for AI inference, which team can do what and deploy which model and this kind of stuff. Quota management, because GPU is a rare resource and it's important to manage quotas. Tenant isolation, you might have multiple teams that should not communicate together, so their workloads should not be the same. All of these things, you are already used to them, and now you just need to extend slightly Kubernetes to make this possible with AI inference. And finally, security with everything that you know about network policies, secret management, certificate management, etc., etc. You have also other ways, naturally, that already exist, like doing CI/CD through Argo CD and stuff, doing backups. All of that is part of Kubernetes that you hopefully already know. So if I need you today to have some takeaways, I mentioned this, the rest of us, the forgotten middle. The enterprises that do not have the budget for GPU clusters, but do not want to tinker with stuff, but also do production grade. This is, in my opinion, the biggest part of our community, and it's growing very fast. As I mentioned about this 44% figure, and many predictions in the industry that says that GPU inference will be very broadly developed until 2030, and it will not cost that much, and it will oversize or be way more in terms of compute than training. For these people that want AI inference at low cost, Kubernetes already have them covered. Hami for the GPU layer, Kaito, llm-d, and all the rest that you already know helps doing this AI inference in an efficient and production-ready way. So I will ask you here to go ahead and give these new projects a little bit of love, use them, test them, create issues, and contribute if you can. So finally, what I would say is you don't need really hyperscalers or AI frontier labs to work with AI and have useful AI in your environments. Standard Kubernetes can do it, and 3 sandbox projects will help you with that. Thank you, and let's have our Q&A. Sorry, okay. So, yeah, so the question is, the question is, what types of slicing does Hami offer? So Hami actually supports multiple types of slicing. There is the Hami slicing that is actually the equivalent of the vGPU approach in NVIDIA. It really intercepts the GPU calls and translates them, I would say. So it's really very close in terms of performance, etc., to native vGPU from NVIDIA. You might know, however, that vGPU in NVIDIA is not supported on all GPUs. It's actually designed more for data center grade GPUs, and that is actually licensed as well. So Hami offers the possibility to avoid all of that and to do it for all types of GPUs, not only NVIDIA. It does support time slicing, and it can work in addition to time slicing or other types of partitioning. So, any projects to help with model training specifically? So, from not Sam Altman, very good. In this specific case, I really focused on AI inference because, in my opinion, I'm seeing the inference as being the majority workload in the near future, the rest of us. However, there are a lot of model training stuff that exists that is more on the Python part. The part where you have machine learning teams that work on improving models and stuff. If you're talking more specifically of how you handle infrastructure around training, then unfortunately I did not study enough to give you examples of what you should do. But I remember like there are a lot about big job handling, because training is more like a huge chunk of jobs at the same time that come for a period of time. So it's not originally designed for Kubernetes, but it can be useful through stuff like Slurm or or other gang scheduling kind of approaches. So the presentation mentioned observability, but how is remediation handled? GPUs are unstable. How is remediation? You mean if you see errors in GPUs, is that what I should understand here? So the GPU exporters will show you the metrics on GPUs as if it were normal CPUs. It's like load and like state and memory state and this kind of thing. So if, I don't know why there is this affirmation that, or declaration that GPUs are unstable, but GPUs are like CPUs, right? It's really compute, but done in a different manner, in a more parallel way. So handling should be more or less similar in that you evaluate the load, you avoid having memory that is full, or this kind of approach. So I don't know what is exactly meant by that, but that's the answer that I can give. Is it possible to bypass NVIDIA CUDA nowadays? So again, I'm focusing my talk today on AI inference. And in AI inference, yes, absolutely. You can completely bypass NVIDIA. Many of these projects actually already suggest that NVIDIA is not the go-to solution for inference anymore. So we have things like Google TPUs, but also TPUs are also used for training, but Google TPUs, AMD GPUs, Intel GPUs. The stack today, which begins with kind of this inferencing pod that is VLLM, do absolutely work outside of CUDA. AMD has a solution called ROCm. Intel, I don't remember the name anymore, but there is also libraries and stuff around that. So, and VLLM is improving very fast to support these additional vendors as well. So yes, absolutely. I don't see any questions anymore. So thank you very much. NV? Sort of like a no problem detector but for GPUs, and it has some remediation capabilities. Yes, there you are. Okay. So, thank you very much, and wish you a very nice continuation.
Okay, so next talk will be by Tomáš Paník from SolarWinds, and it will be about AI agent sandboxing.
Thank you. Hello, everyone. I'm Tomáš Paník. I'm from SolarWinds, located in Brno. And in SolarWinds, I work, SolarWinds is observability company. We do observability products, and I work on observability of Kubernetes and observability of CI/CD pipelines. And also, I work in a project where we try to transition our AI SDLC from kind of AI-assisted workflow to AI native. So this is where my knowledge comes from. So the speech is about the sandboxing. Just 1 hour ago, there was some very interesting panel discussions about dangers of AI, and the panelists mentioned a lot of challenges. The truth is that companies will go after the velocity that comes with it. The YOLO mode, the famous dangerously skip permissions in cloud code, or auto-approve mode. It's opening like big velocity boost if you are able to run multiple agents in parallel using YOLO mode, and you have parallel sessions. Actually, right now, while having this talk, I run like 4 cloud code sessions on this laptop. The talk that is about how dangerous that is. Anyway, this year is the year of transition, where the companies are trying to transition to use this. As Boris Cherny said, the coding is solved. So this speech is not about, the YOLO mode is not bad. I will try to explain how to use YOLO mode safely. So some facts: the coding agents are great in coding, also great in hacking, and unsecured by design. That's the fact. We want the first, but if you combine the second and third, you conclude that the coding agents will eventually try to hack us. This was explained by one of my peers in some internal research, where he very easily tried to leave out of sandbox, and it took like 20 tokens. But that's like, it's the agents are not doing that on purpose. Then they are meaning it like they're trying to help. So now the sandboxes. Let's first talk about some attack surfaces and the real incidents that happened, so you can understand better how dangerous that is. In like 10 years ago or 20 years ago, it was SQL injection, the thing. Today, like the AI agent is very similar, but it's more dangerous. It can be README, it can be GitHub issues, it can be PR command, whatever. It can contain this kind of instructions, which cannot be seen visibly, but the agent can read them and can ignore all previous instructions, read all the credentials, and send it somewhere. This was like real CVE that was fixed in Cloud Code, like in June, where it was proved that if Cloud Code reads this, he is able to send without any need for approval using the ping, the credentials using pings to some DNS addresses. So, and the ping is auto approve, was auto approve, is no longer there. It was fixed. Also, there was an incident where there's a very good blog post in this link where the author is talking about the container, that the container is not a sandbox. That's true. The container was designed for a totally different purpose, and it's very easy to leave the container by agent. And he proved that if Cloud Code had a task and the sandbox was standing between the agent and the task, the cloud code quite easily left its native sandbox. You know, it was not container; it was its native sandbox. But he found a way, discovering some binary which he could use. He eventually disabled the sandbox and then continued on the task without the sandbox. So it's important to understand that there are multiple layers of the sandbox, and the containers is not the sandbox, and neither we will see in the future slide, neither the cloud code sandbox is not. There was a very interesting incident caused by Google anti-gravity. I will just paraphrase this because it's very interesting. A user asked AI coding assistant to clear a cache. Turbo mode auto-execute was on. Agent ran llm-d/s/q on D root instead of the project subfolder, and entire D drive gone. Then the user asked the AI agent why he did that, and he was apologizing. You know, we are observing very good throughput of apologizes. There were a couple of more incidents which I could mention. This one was highlighted in Hacker News, in April. And also in routine staging task, the user was doing some maintenance job, and agent decided to fix the job by deleting the whole volume, and the production database was gone in 9 seconds. Again, auto-approved, and again, agent was apologizing. I will not paraphrase this. Another incident, Replit agent, he deleted production database, then faked the records and lied about the test results, again apologized. And the third which I found was the incident where the agent actually pinned in the project some vulnerable dependency, which actually contains some crypto miner. So agents, all the tests passed, it was fine, but the crypto miner was deployed. And you know, we are seeing the consistency on the metrics. You know, 0, 0. So in general, you can see that the threat is real. The incidents are happening, and there are I identified 6 attack surfaces. The prompt injection, it was already mentioned. The abuse of the tools, you know, the agent has access to the tools. He can use whatever he wants. He can run the bash scripts. He can send curl credentials using curl somewhere. He can modify anything on the file system. This is extremely dangerous in terms of Git hooks, because even if you are in the sandbox and you have mounted volume, like the workspace, and he can put whatever he wants in Git hooks, and whenever you run some Git commands on the host, then you're busted. And network, of course, he can post the data anywhere. And supply chain. I'm from SolarWinds. We all remember the sunburst. We were attacked. Our supply chain was attacked. And this is where agent can do a lot of damage. For example, modifying npm post install scripts and so on. And the agent can also sometimes try to fix something that he wasn't asked to fix. But also one thing to mention, that even Anthropic documents in its documentation that there is the escape hatch. Is that if the Claude decides that, and he runs in sandbox, and he decides he should run some command outside of the sandbox, he can. He is allowed to dangerously disable sandbox and run whatever tool he wants. So that's documented. It's fine. It's the honesty, intellectual honesty. We should be honest in every tool like that. It's not criticism, but So now let's talk about the comparison of the tools we have to mitigate this. But first, I talked about Git hooks, but also dangers regarding mounting volume to the sandbox or in other places. The agent could modify the npm package JSON. So whenever you run the npm install on the host, you're busted, potentially. And some other similar techniques. So I categorized the sandboxes into tiers, and there are two categories of tiers. One category is how difficult it is to leave the sandbox. For the first tier is no sandbox running YOLO mode, so no boundaries. There are sandboxes which are doing syscall restrictions. This is specifically for Mac or Linux. Mac has seatbelt and Linux has bubble wrap. And for example, the Cloud Code sandbox is designed with this. And the containers, of course, tier 3. I put it in as tier 3. There is special tier because there is one tool gvisor which is hardening containers. So I put it to extra tier. A bit better container, and the last one is hardware virtual machine or micro VM. Those the strongest sandbox we currently have. And the second category which I tiered is the network control mechanism, because some sandboxes has some network control mechanism, some don't. So we also have to categorize this. This is the same. First insist none. The second, all or nothing. You can disable network or not. Then layer 3 or 4 boundaries. This is typical case of some kind of default Kubernetes network policies where you can disable by domain. Tier 4 is stronger domain list restriction plus some proxy, where proxy could inject some credentials. I will explain that later. And the last layer is layer 7 inspection, which means that the sandbox can inspect the HTTP packets and can filter, for example, the post and pass through the gets or something like that, which is extremely difficult to do, but some sandboxes can do that. I analyzed a couple of sandboxes, and this is where I ended up. I hope it is visible. There are some interesting ones. The containers I put in tier 3 of leaving the boundary, but usually they don't have network restrictions. We'll talk about that. But the only one which I put into top right corner is OpenShell, which has the provider for using virtual machines. Actually, the Kubernetes ones I put on layer 3 in the network, but it's actually not right because its default network policy is CNI, Calico. It would be on 3, but if you use the Calico with Istio, for example, it would be on 5. If you use Cilium, it would be also on 5. So this depends on the CNI which you use in Kubernetes. So with Kubernetes, you could also reach quite easily the top right corner if you use Kata with Kubernetes and some good CNI. So now let's go a bit more into details of individual sandboxes. We have dev containers. Just raise the hand. Who of you have dev container JSON in your repo? Some hands. And keep hands up if you denied some capabilities in the dev containers. No one? I thought that. The dev containers are not sandbox, as I said. It's not it's quite easy. They share kernel. It's quite easy to leave the sandbox. But it's better than nothing, right? It's for sure. They were designed to be consistent and reproducible environment, not for security reasons. But there are some things that you could do to harden it. First, you can drop the capabilities, because some of the capabilities are useful for agents to leave the sandbox. For example, by default, the agent can read the processes on the host, but if you disable the capabilities, he cannot. Of course, you can disable network, but it has some caveat. And you should also set him some user. But if you disable network, of course, you don't, you cripple the agent quite a lot. He cannot do npm installs, he cannot use MCP tools. So it would be unusable. But you could go around that if you configure IP tables on the host. In our company, we have some peers do that. We have some toolings for that it configures IP tables and do some proper, better network limitations. But still, there are some better ways, right? The Docker currently released Docker sandboxes, which does all of that for you. So let's now talk about that. Docker sandboxes is currently in preview, so it's not released thing. It used to be released with Docker Desktop, but now it's like separate. It's like special binary called SBX, and it's very easy to create this in the sandbox. They have some supported, let's say, agents where they pre-built images with those agents, like Claude or Copilot CLI or Codex. But they also have like a shell template where you can put whatever you want. And you just SBS create a sandbox. And then, as you can see, there's some default network policies in place. By default, like most of the unknown things are disabled. They have some allowed list by default. But you can like configure it using SBS policy allow and quite easily configure where the agent could go and where it cannot. So I would recommend you to take a look at this. It's definitely better than containers for agents and boxing. It's not container. What Docker claims is that it is micro VM. So each sandbox has its own kernel and has its could have its own Docker daemon. And they have some interesting proxying of credentials. And I have it on next slide. But this proxying is like, there is only some allowed list of services which it can proxy this way. It works the way that there are no credentials in the sandbox. And for example, if you use Copilot CLI in the sandbox, it requires GitHub token. But in the sandbox, you set some proxy managed GitHub token. And there is a proxy by this SBX, which injects the credential to the request. So whatever the agent uses, if it's GitHub CLI or if it's an MCP server or whatever, the sandbox proxy will inject the credential to underlying HTTP request which is sent. So the actual agent is never see the actual API token, so cannot like send it somewhere. So this is the architecture pattern, which is used by several sandboxes. I mentioned it here, but OpenShell has this as well. In SBX, as I said, this is limited just to several vendors. It supports the GitHub, Anthropic, or some like there is a list of tokens which it supports, but it cannot be like generalized to for your custom services. So those custom services and secrets, if you want the agent to use those custom services, it still needs to live in the sandbox, which is the advantage here. Okay, let's now talk about Cloud Code sandbox and OpenShell. Cloud Code sandbox can be quite easily enabled. There is just sandbox enabled through, and it has some proxy, so it has also some allow list where the network traffic is like disabled if you try to access somewhere else. There is also like restrictions on the file system, so it cannot then easily touch something. But as I said, this could be like workable. He can go easily around that, but still better than nothing. So if you use Cloud Code, I recommend enabling that. This works only on Mac or Linux because they have this native syscalls restrictions in the file system. Windows doesn't, but usually the Windows users use this, WSSL version 2, which has that. So for Windows users, there is that VSL. There are some interesting facts mentioned in the documentation. For example, this TLS traffic, the Cloud Code doesn't inspect the HTTP request, which means that there is some threat like vulnerability to domain fronting that they mention it in documentation, which means that if the packet goes to github.com, but there is a special header called host, which like targets to some malicious website. The proxy doesn't see it because it doesn't inspect the request, but the CDN where it arrives will redirect the request there. So it's very vulnerability, the vulnerability to this threat. And the read, edit, and write user permissions are handled using system restrictions, which is fine. Okay, now let's talk about OpenShell. OpenShell is a project which is in alpha stage. It runs also in developer workstations, so it is possible to run it on your own machines. It actually it has a Kubernetes plugin, but it's like experimental, and they claim it's like it can contain a lot of breaking changes. But the installation is very easy. You run like single command. You run OpenShell sandbox create to run the sandbox, and as I said, the OpenShell is able to. There's some special certificate. I don't know how they do it, but they inject certificate into the sandbox, and they are able to inspect the encrypted requests using that. So they are able to filter packets also based on a route where it goes, and also on the method. So you can, for example, restrict to some specific domain only post request. For example, if you decide to restrict all the pull request creation requests, you can do it using this policy. The policy is YAML. It's quite easy to read, and there's a approval. It works like that. Then there are some caveats, like that it's still alpha, experimental. But there are like 3 providers. One default one is it runs on Docker. So if you have Docker desktop, you can install it and it will use that by default. And there is also like it can run on Kubernetes in experimental. Okay, so I have detailed metrics where I put all this stuff into the table. I don't know if the interesting ones are those that has micro VMs, and interesting ones are those that are easy to use. I use Docker SBX and some projects. I use also containers because we have some tooling in the company on top of that. I'm following the OpenShell, and those other things I'm just following. And Kubernetes, we have some plans with that, but it's out of my focus at this point. Okay, so I did some, let's say, guidance what I recommend you to pick in some specific use cases. If you are like sole developer, have occasionally YOLO, like auto-approve mode, Docker like sandboxes are like logical pick. If you like to have like more granular control or have requirements where you need to have network restrictions more granular, you can play with OpenShell. And of course, Kubernetes. Does anyone use Kubernetes to run agents? Very good. Yeah, it's very easy. You can run agents like jobs. There is runtime class name, which gives you the escape boundary. In this case, it's kata, like the VM escape boundary. And the network policy gives you the control over network. So it's very easy to configure. And then you can run like the fleet of agents with whatever use case you want. And yeah, what happens if agent goes rogue? Like the 4 questions you should ask are this one. If the stakes are low, go with Cloud Code Native because it's easiest to install. You just enable it. For some local projects, use Docker SDK, the Docker sandboxes, and for other cases, for enterprise or other projects, please use micro VMs or with some fine-grained network policy. We speak with Docker a lot in SolarWinds. We are partnering with them, and one of the PM of Docker said that you should never run YOLO without a sandbox. Yeah, a lot of people accept the risk. I also accept the risk. That's fine. But you should be aware that there are those risks, and those risks are real. So just pick the tool from the metrics. Run it today. I'm not here to stop YOLO mode. I'm just here to put there some padding. And that's end of my speech. So I'm still using YOLO, and I will. Any questions? Yeah, does SBX require Docker daemon? Actually not. They completely separated it. So SBX can be installed even without Docker Desktop. And I have Mac, so you can just, if you have Mac, you just use Homebrew to install SBX, and you don't need to have Docker Desktop installed. So it has some kind of its own like daemon separate from Docker Desktop, so it doesn't need to be. There is now a Kubernetes SIG agent sandbox. Did you have a chance to take a look on that? Not yet. Thank you for pointing this out. I will take a look. And some tools can filter out secrets. Can they as well filter P2? What is P2? Personal what?
Personal identified information, like GDPR, address, name.
No, I'm not aware of that. As I mentioned, the Docker sandboxes can inject secrets, but the OpenShell can do that as well. It's very much better configurable. In OpenShell, you can configure injecting headers to kind of any provider, not just those predefined ones. But I'm not aware that they could be like stripping out the secrets out of the HTTP request. I don't know. What about YOLO versus auto mode? Any hints on that? Well, you mean auto mode, this like mode which is auto approving all the questions and this kind of stuff, right? I'm not a fan of that. Of course, as I said, YOLO mode is absolutely must in the enterprise these days, because if you run multiple sessions, you cannot approving individual stuff, which is asking you would not be doing anything else than just approving. So the YOLO mode is must, the safe YOLO mode is must, but auto mode means that you are giving more control, that he will be answering the questions that agent would normally ask you, which I'm not fan of, and I'm not using that because when those questions are sometimes important when we are defining specifications with agents, letting agent define the specification and during the questioning, letting him also answer, you are losing the control over the whole process using that. So I'm not using this auto mode. Okay, thank you very much.
Okay. Okay, in a few minutes we start the section of lightning talks. There will be a few of 5 minutes short talks for you to enjoy. Okay, and one information before we start. At 6 p.m. there will be a group photo in front of the building. So anyone interested, which should be everyone, should go. Yeah, Everyone is interested. Yeah. That's imperative. Yeah.
Okay, I think we can start. Welcome everyone. This is my favorite time of the day because we are having our lightning talks. In the past, we were also doing some sign-ups during the event, but we were lucky enough that we had a lot of submissions for the lightning talks today. So we are not getting any sign-ups on the spot. I will just introduce. It's called Lightning Talks, which means that we really want to have like short on-spot talks on many different topics. We have today 6 presentations, and I'm happy to introduce our first speaker. It's Bex, or Brian Exelbeard, who will talk about the 139 euro monitoring stack. So Bex, stage is yours now.
Thank you. As she said, I'm Brian Exelbeard. I'm Bex. I work for Microsoft doing Linux, and this talk has nothing to do with that. I also want to point out a couple of context details. The 139 euros in this title, it's not a typo. That's actually what my monitoring budget was, and I wound up spending a lot less on this project. And lastly, the context for all of this is a critical piece of load-bearing infrastructure that I work on that simply cannot have fault. You're all familiar with it, of course. It's puzzlesecretary.com. So puzzlesecretary.com is a social games sharing site that creates leaderboards for folks. And you know how gamers are. Things have to be running. But I also need to make some confessions. It's not running on a cluster. It's actually just one little Azure VM running flat car, bravely facing the world without a service mesh. But it needs monitoring. So we learned in the keynote this morning, how do you do monitoring? Well, you need logs and Prometheus and Loki things, and you need dashboards and traces and something called RUM that was on one of those slides. Not the good kind, apparently. You need a way to blow up your phone, and you need to spend a weekend wiring all of these pieces together and write a small galaxy of YAML and watch your soul leave your body. I love all of you who do this for a living, but do not want. I was trying to figure out if there was a better way. And a few more confessions. I don't look at dashboards. I don't have a monitor in the corner of my office that shows me traffic stats or usage that I check every morning. I literally never open the dashboards. So I need a system that's going to yell at me, not one that's going to wait politely to be consulted. And so I found a solution. I installed Home Assistant. Yeah, that Home Assistant. The 139 euros, it bought me this HA green that you see here. It is pictured here installed in my data center. Now, Home Assistant is not crazy. Like, it knows how to blow up my phone. But Home Assistant does something no other monitoring system can. It can haunt me. Home Assistant sets it up such that nothing says Sev1 like your living room being disappointed in you. So this isn't actually crazy. Home Assistant has a time series database. I know this because it monitors all of the temperature sensors in my home. And what is CPU load but like temperature for nerds? It has graphs and dashboards that I also don't look at for Home Assistant reasons, but I know that they do exist. I happen to use MQTT to send all the stats from my app to it. My Home Assistant already does MQTT because I have a light that was annoying and insisted on using MQTT. It does alerting and notifications. We saw that in the pictures of my phone getting blown up and me being threatened with calls to my mother. But interestingly, it's also a piece of infrastructure I can rely on because it's on my Tailscale VPN, because I don't expose anything to the internet, because I'm a reformed developer, not a security person. And it's always on 24/7, because if it's not, I have to turn on the lights in my house using a switch like an animal. So that's what I used. Now, this isn't crazy. There are dashboards, as I said. I don't look at them, but it is nice to have a curve whenever I need to see if something went wrong and what was going on right before that. This is an example of one that I've got. This is the whole architecture that I've got. My application runs in containers on my VM. There's an extra container from our friends at InfluxDB called Telegraph that grabs system stats as well as custom stats about my application. spits those out as MQTT messages over my Tailscale telnet, where they land in my data center. Home Assistant logs them and then decides if it needs to haunt me. That's it. That's the whole stack. Now, I want to really kind of bring this home with, this isn't actually, I set out to do something crazy to make a lightning talk. I got here by asking myself 3 questions. What do I already have, already know, or already pay for that can solve my problem? How can I not have to bring my day job home for my side project? My goal is to play games and improve Puzzle Secretary, not build a platform for my platform. So this lets me stay focused that way. Home Assistant provided all of the pieces that I needed here, and everything works great. I'm getting, I think, the hook over here, so I will be quiet and say, I'm Bex. The slides are at this link. Thank you very much.
You actually had like, 30 more seconds, so.
Oh, I'm sorry.
Yeah.
I would have said more things.
No, but you can ask more questions during the social event. Are you coming there? I will be there. Okay. I still have 1 more ticket, so if somebody needs that, just come to me after this session. Or you can raise your hand now until Mohamed prepares his slides. Yeah. Do we have anybody here without the ticket for the social event? No? Ah, there, I can see it. Do you want to go?
Where is my...
You can go. Yes, you can. Here you go.
Okay.
Thank you. Yep.
Anyway.
Oh, we will get you. Yes, yeah. You had it, so we will have it.
Anyway, hi everybody. My name is Mohamed from Mirantis, and the next 5 minutes I want to convince you that we as the CNCF community are paying attention to the wrong slice of the AI market, which is the big hyperscalers and the AI frontier labs. But I believe that the future of AI on Kubernetes will be a lot smaller, more dedicated, and more cost-effective. So every AI headline this year, or even last year, to that matter, sounds like one of those. 1,000 clusters and big data centers, $10 billion data center, and the new model at Anthropic and its performance topping the charts, et cetera, et cetera. However, all of these are, even though they are important, they are impressive, and the use cases do make sense, they are probably not for every one of us out there. So if you look at some of the studies out there, the consensus, and there was a specific research at Gartner about this, estimate that at least 65% of AI compute will be for inference by 2029. In my previous talk, I also mentioned another figure, which is that already this year, in 2026, 44% of enterprises are allocating 65 to 100% of their AI budget for inference. So I think we can easily say that AI inference will be major in the next couple of years. And actually, it does make sense, because if you look at training against inference, it's the kind of make once, use many, right? So you train your model once, and then you use it multiple times or even millions of times if you look at AI frontier labs. So you can think about the same approach for smaller scale, right? So who are the companies that will need AI inference, these 44% or more, that are already on Kubernetes? But basically all of them, right? And some have very strict needs in terms of data handling and where the data goes, etc. So you can talk hospitals, banks, factories, public sector, everything. However, we speak a lot, or at least in these bigger events such as KubeCon, etc., we speak a lot about AI ML, like machine learning and particular training. So many of the talks assume that we need multi-tenant GPU fleets and 100K GPUs, but this is not necessarily the case. The CNCF has already everything that you need to answer to the AI inference needs. And there are multiple projects from sandbox to matured ones, etc., graduated, that will provide you with the results. Some of them are, and I mentioned in the previous talk, Cluster API for infrastructure, Hami, Kaito, llm-d, and others, many others. So what do these unlock for you? These make AI inference on commodity hardware and consumer hardware really accessible. And it offers you scalability, it offers you efficiency. For example, multiple use cases mention a 10x improvement in GPU utilization using Hami, for example. So this will achieve lower infrastructure costs and all of that on-premise. So let's stop optimizing for OpenAI and Anthropic and start optimizing for everyone else. These frontier labs will be fine, and the 90% of enterprises will need to appropriate this new stack to do actual production-grade inference on-premise. So the future of AI on Kubernetes will be small, shared, and everywhere, thanks to things like Cluster API, Hami, Kaito, etc. So let's build this 90%. Thank you, everyone. So this is the QR code. I don't think we have time for QA anyways.
Yes, okay. Thank you so much,
Thank
Mohamed.
You.
Yeah, we will have time for Q&A during the social event, I think.
Okay.
Or maybe tomorrow when you meet Mohamed.
Thank
you so much. Vladimir, come. Perfect. So our next speaker will be, until he gets ready, it's Vladimir Sokolenko, who will talk about what Kubernetes native CI looks like in practice, lessons from Conflux. So we will give him 1 minute, and then we will start.
Hopefully. Hello, everybody. My name is Vladimir. I work in the Red Hat as Senior SRE, and today I want to show you what Kubernetes native CI looks like in practice, using a project called Conflux as a real-world example. Just a couple of words about what Conflux is. It's an open-source CI/CD platform for the full software delivery lifecycle, which is fully built on CNCF and open-source projects like Tekton, Buildach, Sixtor, Argo CD, and Kubernetes, of course. Anyone can use it, download, install, and contribute. So how does the build actually happen? You have your Git repo, it sends a webhook, and from that point, everything is just Kubernetes resources. A pipeline run is created, which is basically a pod running your build. The image gets pushed to a registry, no magic, no proprietary engine, just Kubernetes is doing what Kubernetes always does. And this is really the core idea I want you to take away. Most CI systems run beside Kubernetes. For example, Jenkins instance serves somewhere, a GitLab runner on a VM. But what if your CI actually run on Kubernetes as a native workloads? Every build step becomes a pod. Your pipeline is a CRD. You can kubectl get your builds. You get scheduling, RBAC, resource limits, observability, all for free because it's basically just Kubernetes. Here are several patterns. First pattern, pipelines as code. Your pipeline definitions live right in the repo in a Tekton directory. A git push comes in, a CEL expression decides if this change should trigger a build, and the pipeline run is created automatically. There is no CI server to configure. Your cluster is your CI. And this works with GitHub, GitLab, etc. out of the box because it's a CNCF Tekton project, not a vendor specific. Second pattern, using OCI artifacts to pass data between tasks. In traditional CI, you'd use shared volumes, shared PVCs, which sometimes create bottlenecks, and can be tampered with. Here, each task is an independent pod. Data goes through the OCI registry, immutable, content addressable, just like container images. OCI, the same image format you already use for applications, now carries your data builds too. Third pattern, hermetic builds. The build runs in two phases, actually. First, you download all the dependencies with the network access. Then the actual build happens with the network completely cut off. If something tries to pull an unexpected dependency during build, it simply can't. On the top of that, Tekton Chains, another CNCF project, automatically signs every build with cosign and generates supply chain levels for security artifacts. You get supply chain security without changing a single line in your Docker file. Fourth and the last pattern, testing and releasing the whole application together. When a component builds successfully, the system creates a snapshot, a point-in-time record of all your component images. Integration tests run against that snapshot. The policy gate checks signatures and provenance, and on success, the release pipeline promotes it to production. Fully automated from git push to production, no human clicking deploy. So to wrap up, these four patterns aren't specific to conflicts only. They're Kubernetes native patterns built on CNCF projects that anyone can adopt. Pipelines as code with Tekton, OCI artifacts for everything, hermetic builds with 6-store signing, and snapshot-based integration testing. The bottom line is CI shouldn't run alongside Kubernetes. CI could be Kubernetes. Thank you. So you can find the QR with the presentation and some useful links.
Thank you so much, Vladimir. And we have, I think, now Martin, right? Don't worry, you can come here. Perfect. So Martin Matias will talk about Prove It, is your Kubernetes app cloud native? So we will give him 1 more minute, and we will learn more.
Okay, hello everyone. I'm Martin from TIETO, and I'm also a member of Cloud Native Telecom Initiative, which is crossroad between telco sector and shifting telco sector into cloud native world. And this is the test suite that I will talk about today. So this will be more return back to cloud native basics. No fancy AI talk from me, sorry. It's about cognitive basic, and we still need to take care about basics, right? So the basic question from me, is your application cloud native? And how you know that, actually? One may say that, okay, my application runs on Kubernetes, so it is cloud native, right? Well, not necessarily. Going into extreme, you can take your monolith application from bare metal and you can make it running in a container, and it runs under Kubernetes, right? But not really cloud native. I think you would agree with me. So this is kind of thing that we take care of. Additional examples, if we want to find anti-patterns of cloud nativeness, for example, stateful traps, right? You can have host path mounts, rateable host path mounts, dependency on workload, and you cannot evict your pod, move it elsewhere. One example. Additional example, the exit of your services or pods in case that Kubernetes needs it. Your service needs to take care of handling of sick term, right? Gracefully and shut down your application. Or the visibility of errors in case that something bad happens in your container. Kubernetes needs to know that, and therefore we have probes. You need to probes have set up. So those are examples that you need to follow in order to be cloud native. So you can work out such list of cloud nativeness, right? And take care that your application follows all of them or most of them. But best if there is already something existing and automated. And yeah, indeed it is. And this is a Cloud Native Telecom Initiative test suite, which implements that. Why from telecom? Well, actually, historically, telecom is a sector that is quite slow to progress, and slow. It was also slow to with going to cloud native, and it still has troubles with having telecom applications adhere to best practices of cloud nativeness. So therefore, we came with the test suite that helps with translation to cloud nativeness. So it's open source project under Linux Foundation networking. We have more than 80 such tests, which is, I think, quite a lot. And it's targeted to telecom-grade applications. And actually, any application outside telecom can benefit from that, I think. So examples, you can have here examples what we test. For configuration resource limits, you need resource limits. Or you need, for volumes, if you need stateful services, you need elastic volumes, for example. We check that. Or from security world, big topic, right? Security. You cannot use root users under your containers. That's a bad security anti-pattern. And go on and on and on. How to run it, how to use it for your applications. 3 simple steps. You can have it in 15 minutes, actually. You need to write simple YAML, which describes target of your application, Helm repository, for example. First step. Second step, install it using CNTI test suite. And third step, run the test and get the results. 1, 2, 3, simple as that. And feel free to use it. We are a vibrant community, and we are here to support you in case you need to help with running of test suite on your application and proving that your application is really cloud native. And we have set of most important 18 tests, which you can start with, and you can get GitHub badge if you comply with that. Yeah. So connect with us. Thank you.
Thank you so much. Thank you so much. And we have our next speaker, Daniel. So I hope that you get some contribution to the project. And Daniel Grigorev will talk about debugging your Kubernetes CI with CrustGather. So can we see the slides? Yes, yeah. Perfect.
Okay.
Yep.
Will it show there?
Yes. Yes.
Oh. Hey everyone. So my name is Daniel Grigorev. I'm a senior software engineer at Mirantis. And today I'm going to show you something which is not related to my work entirely. It's more of a hobby project, which I was developing for a couple of years. And there are some use cases you may utilize this in. So I'll fire up the demo. As you can see, this is a recording of how it works. What I'm going to do here is create a simple cluster. Any Kubernetes cluster will do. And when it's done, you can, for example, imagine a scenario. This cluster is your CI. In the CI, you're testing some workloads, you're deploying some things. AI, not AI, anything like development workflows, and you run end-to-end tests on them. You want to verify that your CI is passing. That's easy. Everyone is doing this. But what if it fails? Typically, you force to write end-to-end tests, to implement all the collection logic, to know what the failure came from. But imagine a scenario. You have a very complex infrastructure developed for this, like air-gapped, I don't know, some vSphere, private cluster, anything else. You basically need to know what happened with your CI without reproducing this as fast as possible, as you want to fix this. And so this tool, what I just did, I just fired it up, and it collected all the cluster states, like all the resources, everything you have, which is not uncommon. Everyone is doing this in their production, in their scenarios, in your CI. But what the CastGather allows you to do is that once you collect this, and actually in this scenario, it collects this whole cluster state into an OCI image. So it's publicly available for you in the registry, and this registry later serves as a file system. So once it's collected, you're getting some information about the cluster. As you can see, some things inside of that, namespaces, cluster resources, versions, APIs, all the logs, all the pods. In the moment of failure, you get all in this archive. You can store it in zip, you can store it somewhere, you can store it in image, and give to your colleague to debug. But what if your colleague is an AI agent? You don't really need to look into this thing, because AI agent can analyze the failure for you. Not only logs, not only the states you've written in end-to-end test, but the whole cluster state, events, logs in the background. Image is there, it's available. And as you can see, I'm starting here MCP server, which CastGather provides. And I'm giving a simple task of explain me what that cluster contains. Maybe some failure in it. Something broke, I don't know, figure it out. It may be automatic task. You fires overnight. So in the morning, you wake up and you get the summary of your failures in CI. You can go and cross-reference them across multiple scenarios, like you have a nightly job which failed for a week. You never noticed this. But now you have all the stored snapshots of your clusters at the moment of failure in your image registry, and you can just basically delegate to AI to cross-reference, to find the issues, and, well, tell you what's gone wrong. And what's happening here, it starts starting from the archive. And what it starts, it's an API server. So it's fully, well, not fully, it's a handwritten API server in Rust. Very simplistic one, focusing on data plane. I didn't go into mentioning the whole thing. It's not production ready. It's just a specific API server for debugging things. And you run kubectl, KNNS, everything sees this as a real cluster. It has all the information, even more than you may imagine. For example, you can specify to pull some node level logs. It runs to the debug pod, starts those executables on your host, collects the logs, and you can see them from this snapshot as served in this scenario. So as you can see, those some outputs that colleagues saw, that's a real cluster, but it's now gone. You don't spend money on this. Your CI is now long gone. You don't need to worry about this. Everything is stored. Everything is ready for you to debug, either human or AI, as in this scenario. So yeah, feel free to come tomorrow. I'm going to have a larger talk about development of this project, some discoveries since it's API server in Rust, maybe some interesting, non-interesting details about how it works, what things I faced, what API server, if you focus this on a high-level perspective in Kubernetes, means, what things don't scale, you cannot create or recreate, and you are basically vendor locked in, and how easy it actually was, even though it was a project which was like Rust, it's a complex one. So yeah, as you can see, the result of this, it tells me that it has NGINX, there are some pods running, some things that pending. You can follow up with this and like explore further, because AI works much better if you go through tool calls and narrow context. It knows what to go next if you have a specific context in mind. If not, you have always a snapshot of the file system. You can go through all the files by yourself. So yeah, that's it. Thank you very much.
Thank you so much, Daniel. Hope you join the Daniel's talk also tomorrow. A teraz sa trošku prepneme ja do slovenčiny, ale Lenka asi do češtiny, teda neviem. Áno, do češtiny. Super. Lenka Kargerová nám teraz možno trošku zachráni spánok, pretože nám predstaví technológiu Split Horizon DNS. Tak dáme jej trošku chvíľku a započúvame sa. Pozerám GM.
Při nejhorším tam necháme tu lištu. Teď jsem ztratila to okno.
Tak. Dobrý den. Mé jméno je Lenka Kargerová. Baví mě automatizace nad infrastrukturou a to mě občas dostává do hodně zajímavých situací. Tak možná mnohem zajímavější, než bych já sama chtěla. Komu z vás se někdy stalo, že vás mezi 1. a 3. hodinou raní zbudil Slack nebo PagerDuty kvůli nějaké aplikaci, která nefunguje? Jo, děkuji. A komu se stalo, že při tom debugování zjistil, že ta aplikace sama o sobě funguje a že problém bude asi někde úplně jinde, třeba na síti, v síťové vrstvě? Jo. Díky, děkuji. Děkuji za přiznání. Já jsem tehdy byla poměrně začátečník, takže mi nezbylo nic jiného, než udělat radost našemu síťaři a zbudit ho v noci taky. A náš síťař mi říká, no ale hele, ty tam nemáš hairpinning. Říkám, co to je, že? A zjistili jsme, co to je, síťař mi pomohl to nastavit. Šlo o to, že se nám data, která patřila do interní sítě, pěkně putovala ven do internetu přes venkovní. Tak to zkusme takhle. OK. Super. Dobře, děkuju. Tak já jsem chtěla po Gemini, aby mi nakreslila obrázek mě, ale ona nakreslila toho síťaře. No, dobře. Takže data putovala vlastně venkem, ta, co patřila do vnitřní sítě, pěkně přes firewall, že jo. Měli jsme krásně přetíženou síť a proto nic nefungovalo. Spoustu let později jsem se potom dostala do situace, kdy ale ten hairpinning jenom tak jednoduše nastavit nešel a kromě toho v tom prostředí byla spousta dalších jiných problémů. A hledání toho řešení mě dovedlo právě až k DNS Split Horizon. A ten klidný spánek mi zachránilo to, že jsem se ho naučila, ale ne úplně to tak dopadlo s tou implementací. Vysvětlím proč. Nejdřív ale co to vlastně je ten DNS Split Horizon. Někdy se taky říká split brain nebo split view a můžeme si to vysvětlit třeba na příkladu, když jste doma a potřebujete objednat balíček pro vaši přítelkyni, manželku a jak popíšete, kam jej doručit. Uvedete adresu, jméno, příjmení, obec, ulici, číslo popisné a když to jde dobře, zazvoní vás kurýr a doručí balíček. Ale v podobné situaci, když jste třeba doma, máte děti se přijdou a ptají se, hele, tati, kde je maminka? Jako, co jim řeknete? Ulici, číslo popisné, pošlete zvonit na zvonek? Ne, že? Řeknete mi, já nevím, na zahradě, v pracovně, kde tak jako se doma běžně vyskytujete. A to je ten split horizon. V podstatě na jeden podobný dotaz ten DNS server vrací 2 různé odpovědi podle toho, kdo se ptá. Tak a teď, proč vám to může zachránit ten spánek? Za prvé, nestane se vám to, co se stalo mně, že budete posílat ta data, co patří do interní sítě venkem, nebudou zvonit na ten zvonek zvenku, nebudou vám přetěžovat firewall. Druhá věc je bezpečnost. Když budete vracet jiné DNS záznamy pro ty, kdo se ptají zevnitř a jiné pro ty, kdo se ptají zvenku, nevystavíte ven spoustu důležitých informací. Nemusí nikdo vědět, na jaké interní IP adrese jede vaše devové prostředí, nebo kolik těch devů máte, jak se jmenuje váš password management a kde je. A ve třetí řadě je to nějaký komfort pro ty dané uživatele. Prostě se nestarají, zadávají adresu a hotovo. Takže to vždycky by se mohli takhle krásně dobře spínkat, ale ono to má své úskalí. Co by se mohlo stát, že? Tak jedna věc je DNS cache. Máte člověka, který pracuje v kanceláři, třeba vývojáře, všechno mu funguje, zaklapne notebook, jde domů, doma notebook otevře, protože si cestou ještě něco rozmyslel, něco si vzpomněl, chce odeslat nějaká data, ono mu to nefunguje, protože mu zůstaly nakešované ty interní doménové záznamy. Takže tam má teď nějakou vaši IP adresu interní a na jeho domácí síti v lepším případě teda na to nic neodpovídá, samozřejmě. A druhá věc je potom nějaké debugování, které je potom hodně složité. A věta od uživatele, mně to nefunguje. Potom dostává úplně jiný rozměr, protože jde o detektivní činnost. Při tom debugování zjišťujete, odkud pracuje, jestli je v interní síti, jestli někde ve vlaku nebo kdekoliv jinde. Takže co s tím? Teď v roce 2026. Naštěstí se to dá všechno řešit, dá se to řešit jinak a docela dobře. V první řadě je potřeba se zamyslet nad tím, co ve skutečnosti doopravdy potřebujete. Vesměs vám bude stačit privátní subdomény, které budou dostupné jenom za VPN-kou, budete na to mít privátní DNS server, a ten bude odpovídat jenom za tu VPN-ku. Je to celkem v pohodě, ať používáte WireGuard nebo cokoliv jiného. Při připojení s tomu klientovi nastaví ty správné DNS servery, je to vyřešené. A je to mnohem bezpečnější, že jo, samozřejmě. Druhá věc, spousta zaměstnanců vůbec nepotřebuje třeba ani tu VPN-ku. Typicky nějakým obchodákům, aby se dostali do CRM-ka, stačí třeba nějaký Zero Trust tunel. Jo, máme dneska Tilescale, HashiCorp Boundary, Cloudflare Tunnels. Krásně se to dá nakonfigurovat, je to pro vás mnohem jednodušší a řeší se to bezpečně, elegantněji na aplikační vrstvě. No a ať už zvolíte jakékoliv řešení, tak co doporučuji rozhodně je vyhnout se takovému tomu ClickOps. Nikdy nic neklikejte ručně, spravujte veškeré vaše DNS zóny výhradně přes infrastrukturu jako kód. Tak. A to je všechno. Když to dodržíte, já doufám, že se vám bude dobře spát. Díky.
Ďakujeme, Lení. Koľko z vás bude už mať kľudný spánok po tejto prezentácii? Zdvihnite ruky. Dobre, máme tam nejaké ruky, super. And we have our final presentation. Do we have Emrah here? Because, okay, we have. Hey. Perfect. So until you get ready, we have Emrah Sifoglu. I'm very bad with this pronunciation. And he will show us how to design a distributed system in hurry for the object storage.
You want to have full screen? The last talk takes the longest one. I need to have full screen. Cool. Good evening. During this last short talk, I'm going to take a quick journey about how to design a system for getting large data. So raw data is stored on storage and needs to be downloaded by many users. When I say raw, I am trying to emphasize actually that it's in a large size, not necessarily maybe in terabytes, but let's say 50 gigabytes. So it is collected, stored there, and you cannot share any credentials. You cannot mount the object storage as a volume or something, and it needs to be accessed securely. So here's an idea. Why you just not serve over HTTP, right? Point a URL at the data on the storage, and then users can download through your infrastructure. Well, that's actually where the problem lives, in your infrastructure. When we are talking about, when we say the infrastructure, we are pointing at the API gateways, proxies, load balancers. But why that will be a problem? Because the connection will be killed, not by a lag or something, not because we have like a low speed, but by just design. So first of all, each system we are referencing here, like the proxies, API gateways, load balancer, has their purpose. They serve an each purpose, and they have hard limits. And one way or another, you will hit those hard limits. And it won't be possible to actually even overcome them because they are not negotiable. You might be saying that, well, I can watch videos on the internet without any issue, right? Yes, especially when you are streaming or when you are actually watching a stream. There are different protocols, one of which is UDP, one is TCP. So UDP is the type of protocol that fire and forget. So package not necessarily will be acknowledged that they are received. So in that case, that will be fine if you are streaming a video, which is the reason sometimes you see some drops in the connection, but you don't understand the person. And that's completely fine, because that's actually one of the trade-offs. But HTTP under the hood uses TCP, and every package must be acknowledged. And when it comes to TCP, we have some limitation. We cannot have that much large packages. Top of that, HTTP overall is not going to, it's not support to download like a gigabyte of data, maybe megabytes. And when you want to actually download the file, the tools we are using already in these days opens multiple connections. So and each connection will go through the system, the infrastructure. And when it happens, what will happen? Well, authentication, authorization, basically refreshing the tokens. So eventually, there will be issue on your side. You will create the bottleneck. So, as I have just mentioned, tools and technologies we are using today already actually have the ability to split into chunks and request like some range of bytes. And then you can actually have accumulate everything on your local environment. So this is already happening. But the problem is about overcome the bottleneck. So instead of going through the infrastructure, what we can do, we can maybe receive a pre-signed URL from directly the object storage, which means we don't need to actually authenticate, authorize, token, refresh. We don't need to deal with any of those, and we will do it only one time. What will happen? We will get the pre-signed URL, bypass basically the sort of the infrastructure. So with this approach, we will be able to overcome the issue that limit, and as well as also we will be able to download the file if there is a connection, for example, drops. So basically, that's it. This was actually quite beginner-friendly. For those of you who are interested in actually building a foundation, I believe this might be, hope you find this useful. Thank you.
Thank you so much, Emrah. And Emrah has also a workshop tomorrow, so check the schedule as well. And this was our last but not least lightning talk, so thank you so much for joining. It's actually also the last session of the day. And now there is a time for some beer and some group photos, right? So please like join us outside of the building. We will take a group picture, and then we will move to our social event for those of you who have tickets with you. So please have it on your hand. Thank you so much.